So till then, if you guys have any doubts, we can discuss them. Anything related to quiz or something you want to ask?
मैम हमारे जो सिलेबस है उसमें फिलहाल वीक 6 भी प्रोवाइड करा दिया गया है, तो वीक 6 की डेडलाइन मुझे समझ नहीं आ रही है।
Yeah, so it is possible that that deadline could be extended. बट आई एम नॉट श्योर। मतलब हर बार वो एक्सटेंड हो जाती है, बट इस बार पता नहीं होंगी या नहीं होंगी। सो आई लेट यू नो इन द नेक्स्ट सेशन। सो आई लास्ट सर अबाउट दिस, विशाल सर, एंड लेट यू नो दैट इफ दैट डेडलाइन इज एक्सटेंडेड और नॉट, मतलब होगी या नहीं होगी। उस हिसाब से फिर आपको जीए सबमिट करना पड़ेगा ना।
और मैम हमारा जो सिलेबस होगा वो वीक 4 तक होगा या फिर वीक 5 और 6 तक?
नहीं, वीक 4 तक। सो वी क्विज 1 syllabus will be from week 1 to week 4.
ओके। बिकॉज मेरा एक फ्रेंड है वो ऑलरेडी एनरोल्ड है, तो वो भी कंफ्यूजन में था कि
हाँ
यार
हाँ
मतलब
हाँ।
वीक 4 तक ही रहता है। और
हाँ,
हम
वीक 4 तक ही रहेगा।
और हम डाउट में थे कि वीक 5 और 6 दिया है तो वहां तक भी रहेगा।
नहीं नहीं नहीं, वो एक्चुअली ये कोर्स 12 वीक का है ना, तो वो लोग वीक स्किप नहीं करना चाह रहे, इसलिए वो कोर्स चलते रहेगा। बट क्विजेस मतलब क्विज 1 के लिए सिलेबस week 1 to 4 रहेगा, क्विज 2 के लिए week 1 to 8, और इंटर्म के लिए पूरा ऐसा।
थैंक यू मैम।
Ma'am, I had a question regarding week one.
यस प्रांजल।
The basic problem that I'm facing is in functions. I cannot
हम्म
identify if there is an equation. I cannot
हम्म
identify if it's like surjective or bijective, like one function or onto function. Can you help me with that? Because there are multiple questions regarding that thing where we
हम्म
have to identify which function it is.
हम्म। So yeah, I'll cover that topic too, 1 and on to functions. So I'll start with basic set theory, then we'll go to relation, and then we'll go to functions. So in that, I'll explain. I try to give you 1 or 2 ways to check that a function is 1 or not, and we'll discuss
Uh,
that in detail.
Actually, ma'am, I know which functions are one, which functions
Hmm.
are onto functions and into functions even. But
Hmm.
like while solving, I just can't understand. I just can't wrap up my mind around where,
Hmm.
let's suppose when we divide domain and range, right?
Hmm.
And
Yeah.
let's say if a function is onto function, but
Hmm.
sometimes my answer, like when I'm solving, it's coming in one function. So I'm confused in that scenario. I don't know how to explain my question properly, but uh, if I
When
like
you're
had a
solving, you're getting that it is a 1 function, but eventually, when you see the answer, it's not a 1 function. Is that
right,
the
right,
case?
right, right.
Huh. So, which method are you using for checking 1 function?
So basically, I'm trying to I use like hit and trial method. For instance, if
Hmm.
uh,
Hmm.
let's suppose I'm taking several example. Let's suppose x is 1, -1, 2, and -2. Most probable range that I'm using. uh,
Hmm.
and then in domain, and then the answer will be coming in that particular range. But sometimes there are
Yeah.
things where
Hmm.
like half is the answer, and
Yeah.
on half it's an onto function. Those kind of things I'm facing a problem in functions.
Yeah. So actually, hit and try mostly won't work if we go for the 1 or onto function. It may work if you get the contradiction. So, for example, if a function is given to you, and suppose you are able to find out 2 points x1 and x2 which are not equal, but the value at these points of a function is taking, those values are equal. So if you get such type of thing, then you can contradict that. Okay, now f can't be a 1 function. Okay, so you can use hit and try method if you are getting something like this. So that means if you are getting a contradiction, but if you are getting oneness at at every point. So for example, you try some values. Suppose you will try 1, 2, 3, 4, or 1, -1, 0, whatever. At these values, if you are saying that since these are 4 different values, and regarding these values, the function is also taking different values. So if you check for these 4 points and you are implying that f is 1, 1, then it's not a correct way. So if you are feeling that okay, this function can be a one function, so you have to prove it. So for proving it, you have to prove two statements. So either you can check this one, that you'll take two arbitrary distinct point x1 not equals to x2, and try to claim that f of x1 is not equals to f of x2. This is the one way you can check. If you are feeling that given function is 1 1, if you are able to check this statement, then only you will say that okay, this is a 1 1 function. Otherwise, by checking at some random point, it's not necessary that the function will be 1 1. Okay, so we are talking about 1 1 because in 1 1 function only we need some values. If you want to check onto, then we have to follow another approach. So this is a one statement, and another one, I guess. So if you consider f of x1 is equals to f of x2, then you have to claim x1 should be equal to x2. So if you are able to prove these two statements, then you can imply f is a 1 1 function. Okay. For example, if I give you a function f of x is equals to something like 3x upon x plus 2. Okay. So suppose this is a one function. So I want to know that f is a 1 1 function or not. 1 1 or not. So what I'll do, yes, I'll try to figure it out. Since it's a linear type of function, I know if I put different values of x, it might come different because here only x is involved. So if x is changed, if you change x, then the function value might change. So I'm guessing that it could be a 1 1 function. So you can check for some values. F of 1 you can check. So f of 1 will be 3 upon 3, which is equal to 1. Okay, f of 2 we can check. That will be 6 upon 4. So it means 3 by 2. So again, these two values are not equal and the inputs are not equal. So it is possible that this function might be a 1 1 function. But you cannot say, you cannot anything claim now. So for saying, for proving this function to be a 1 1 function, you have to check one of these two statements. Or if you know the graph, you can go with the horizontal line test too. If you know the graph. But here, this is a rational function, and the graph of rational function we cannot draw that easily. So we have to check one of the two statements. Okay. So what we can do, we can either check the first one or the second one. So let's go with the first one. So suppose you have two distinct values. So whenever you are working with a proof, you always have to go with abstract quantities. That means x1 and x2. You cannot take a particular value in place of x1 and x2. So what you have to do, you have to assume x1 not equals to x2, and somehow using some logical steps, you have to imply f of x1 is also not equals to f of x2. This is our claim. This is what we want to prove, and this is our assumption. So what I'll do, I try to construct this expression here over the left hand side and the right hand side. So I know x1 not equals to x2. So that means 3 times of x1 is also not equals to 3 times of x2. This is kind of obvious. If we have two distinct real numbers, the constant multiple of those two real number will always not equal. Similarly, if x1 not equals to x2, x1 plus 2 is also not equals to x1 plus 2. Right? So now these two quantities are not equal. I can say, okay, 3x1 upon x1 plus 2 is also not equals to 3x2 upon x2 plus 2. Right? So that means I can say f of x1 not equals to f of x2. So in this way, I assume x1 not equals to x2. I prove f of x1 not equals to f of x2. So the main point is, if you are getting feeling that okay, the function can be a 1 1 function, you don't actually rely on finite set of values. You have to check this statement, first one, or the second one, or the horizontal line test for saying it is a 1 1 function. But if you find out two values which will contradict the definition of 1 1 function, that means at two distinct input points you are getting the same output. In this case, you can just simply using by those values, you can say f is not 1. Okay, so there are two ways. For saying f is not 1 1, you have to find out two distinct input values for which the output is same. And for saying f is 1 1, you have to check one of these three results. Okay, so either horizontal line test, or the first statement, or the second statement. So that's how you have to approach for 1 1 function. Is that okay?
Yes, ma'am.
And for onto function, for onto function, we have to check that the range is same as codomain. Range of f is same as codomain. And if the codomain is not given to you, you assume that it's nothing but the whole real number set. So for this thing, what you will do, for a point in output, so that means for any y belongs to real number, you try to find then x belongs to real number such a way that if you put x as an input, the function will give us y as an output. So this is the one way for proving that a function is onto function. But if you want to say that okay, this function is not an onto function, what you will do? So this is for proving onto function. And if you are getting feeling that okay, this function might not be an onto function, so what you have to do? So for that, for saying it is not an onto function, you will find a real number, y, a real number or any number from the codomain, in such a way that number does not have any pre-image, right? So find a real number or find any element from the codomain y such that there does not exist any x which maps to y. Okay, so you have to say in that way, you can say that okay, because for this y, I'm not getting any pre-image, so this function is not an onto function. For example, x square function. X square function, we know this is the graph y is equals to x square. So here, if you consider y is equals to -1, then I don't have any real number for which f of x square is equals to -1, because we know that square always become positive. So in this case, this -1 will works for me for saying that y is equals to x square is not an onto function. Okay, so there are two ways. So one way is, if you feel that a function is onto, try to prove it onto. If you are able to prove it, then you can surely say, okay, this is my proof and this will work. So it's not, it is an onto function. But if you want to say that it is not an onto function, you just have to find a y for which for which we don't have any pre-image. Okay, so these are the
How
two
do we
different ways.
prove? Mm,
Not audible, ma'am.
So
Ma'am, you
suppose
are not audible.
hello, am I audible now?
Yes, now.
Yes, ma'am.
3x upon x plus 2 we have. So I want to say that this is an onto function or not. Okay, so what we will do for an x, so what I want for any y naught belongs to real number, I want to find an x naught belongs to real number such a way that f of x naught is equals to y naught. If I want to claim that this is an onto function, and this should happen for any real value, for any real y naught. So what I'll do, I'll just substitute these two values here. So y naught will be equal to 3 of x naught upon x naught plus 2. So now what you will do, you'll try to express x naught in terms of y naught, so that I can, if I substitute it back in this expression, I will get y naught. Okay, so you are getting my point, right? So I want to find the value of x naught known to me, and this y naught is given to me. This is given to me. I want to find this x naught. So here we want to find x naught. That's why we are expressing x naught in terms of y naught. So this is given, and this I want to find. So we can simply use some algebra. So I can say y naught x naught plus 2 y naught is equals to 3x naught. And x naught y naught minus 3x naught is equals to minus 2 y naught. So this will implies x naught I can take common, y naught minus 3 is equals to minus 2 y naught. And this will implies x naught is equals to minus 2 y naught upon what is this, y naught minus 3. Okay, so now what will happen, if you substitute x naught here, this value, you will get output as y naught. So using this, what I did, so here no matter which y naught I will choose. So suppose I have y naught is equals to 5. So for this 5, I want to find a pre-image if my function is given in this way. So using this formula, I can find out pre-image. Then x naught will be, just substitute 5 there. So minus 2 into 5, 5 minus 3. So that will be minus 10 upon 2. That is minus 5. So that means if you put minus 5 here, you will get output as 5. So here there is nothing new in 5. So that means this function will be an onto function. Because
Madam,
for
but
any y naught, yeah, but yeah, domain you have to restrict that obviously x naught equals to -2. And with -2, same thing for inverse here also, that y naught not equal to 3.
Every time we have to prove this all minus 2
If you
y
are
naught.
feeling that a function is onto, if it is onto.
Hmm.
Otherwise,
and
if you know the graph, then by the graph it's very easy. Just use the vertical line test or just
no,
find.
sorry, madam. Again, last time I asked same question. Until
Hmm.
unless the domain is not given, then if it is a real number, whole real line, then this is not onto.
Yeah, this is not even the function then, because it is not defined at x is equals to -2.
Oh, it's not even a function. Okay,
If
correct,
right, because at
correct, madam.
-2 we
Correct.
don't know the value.
Yes, yes, correct. Yes, madam. Thank you.
Okay.
Ma'am, I think we should start set now. We will
Yeah,
discuss
yeah.
this more in next sessions.
So 1 and onto is yeah, it needs some practice to prove. Okay. So let's start with our basic set theory. So you guys know what is a set? Set is nothing but a well-defined collection of objects. So by meaning well-defined means there should not be any ambiguity in the elements of sets. For example, if I tell you that I'll collect all the cities in India, then it's kind of obvious that which cities are in India. So it's a well-defined collection. So any well-defined collection is known to be a set. Now there are several operations related to set. So I'll just briefly explain them. So you guys know what is A union B is. So here it is a set in which you have to collect all elements which belongs to A and X belongs to B. Sorry, not and or. So X belongs to A or X belongs to B. This is the union. So that means you have to collect elements from A or from B or from both. That one. Now the next operation is A intersection B. So in A intersection B, we have to collect all those elements which are common in both A and B. So we have to collect all those X which are common in A. So that means X belongs to A and X belongs to B. So here, usually OR stands for union and N stands for intersection. Now there is next operation which is known to be A minus B. So A minus B means you have to collect all those elements from A which are not in B. Okay. So that means A minus B. So we have to collect X such that X belongs to A. Sorry, we can simply say that X belongs to A and X does not belongs to B. Okay, so any element with these two conditions will be in the set A minus B. So A minus B means we have to collect all those elements from a set A which are not in a set B. Okay. So and the last one is A complement. So this complement depend on the universal set. So which universal set you are taking. So suppose we have U as a universal set. Okay, so suppose U is the new universal set. Then A complement is nothing but U minus of A. So that means you have to collect all those elements X which are in U but not in A. So that means X belongs to U and X does not belongs to A. So this set is known
Can
to
you
be A
repeat this
complement.
A C?
Yeah. So A complement means what is the A complement means? So suppose you have some bigger set U. So this is your universal set U. And here you have another set A which is inside this bigger set U. Okay, because for defining complement we need a bigger set. Then only we can say that okay, some elements we have to take all those elements which are not in A. So suppose this is your universal set U and A is a set which is inside this universal set universal set U. So in A complement we have to collect all those elements which are outside of A. This portion is nothing but A complement. Okay,
Which
is
is
that okay?
universal?
So universal set is any bigger set you can take, any set which is bigger than. So if someone
A
asks you
must be
about five,
inside.
sorry what?
A must be inside.
A must be inside. So
You
any
wrote
set
outside.
which containing A. So if someone asks you about complement, they usually give you the universal set U. Okay, and then only they will ask about complement. So these are the 5 operations we have seen in our course. So now let's talk about Venn diagram. Is there any doubt in these operations? These are the only four operations we use. And one is the Cartesian product, A cross B. Right? So in A cross B will contain all those tuples A comma B, where A is an element of A and B is an element of B. So we have to collect all the pairs, A comma B type of pairs. Okay, so this Cartesian product
And can
can be
you
defined for
just
smooth one.
define the fourth one?
This Cartesian product?
A minus B.
Yeah, so A minus B means, suppose, again, we have a Venn diagram here. So suppose this is our universal set U, and here I have two sets A and B. Suppose this is A, this is B. So that means A minus B means we have to select all those portion which is inside A, but not in B. So this will be our A minus B. Okay, and if you consider this whole area, then this will be our A union B, because these points will be inside A, also inside in B. So this will be your A union B, this red one. What will be A intersection B? So A intersection B will be this portion. This will be A intersection B. Okay,
Center part.
and this will be, sorry, what?
The
The
center
second
part,
one.
A intersection.
So A intersection B will be this intersection part, because this part contain all the points in A, also in the points B. Right? So this will be A intersection B. So this is known to be a Venn diagram. So a pictorial way to demonstrate the
A
set.
union B, whole
Whole
A and B.
whole area, right? Which is inside A, also in inside B. This whole area covered by A and B.
Okay.
Okay.
But it also include the intersection area. So can we conclude it?
Yeah. A union B contain all those points also which are in A and in B both. So A union B means you just have to collect all those points which are in A or in B or in both.
Okay.
Okay. So here I think I have mentioned just or in X belongs to A or B or both. You can also write or both. Okay, because union will collect all those points which are in A or in B or in both. Okay. So now there are two main formula which you have to remember for solving counting problems. So one is cardinality of A union B. So we can find out cardinality of A union B using this formula if we know the other quantities. So cardinality of A union B is cardinality of A plus cardinality of B minus cardinality of A intersection B. And if you want to find out the proof of these theorems, you can just go and search. You'll find there are so many ways to prove these two formulas. Okay. The second one is, in place of two sets, if I have three sets, then how you can find out the union. So A union B union C is equals to cardinality of A plus cardinality of B. Again, cardinality means number of element in that set plus cardinalities of C. So for remembering this formula, you can say what you have to do. You have to add all cardinalities, then subtract all twice cardinalities. That means A intersection B, B intersection C, and C intersection A, and then add the third one, that is A intersection B intersection C. So these are the two commonly used formulas for finding the values in counting problems. Okay, so you can remember these two formulas. Also, you can guess which region in the Venn diagram belongs to which portion. Okay, so that's kind of easy. So let me ask one question here. So suppose I have this Venn diagram. And if I ask you, so suppose these are sets A, B, C, and suppose I'll ask you, what is this portion refer to which set? So that means this particular portion refer to which set? So what will be your answer?
A intersection C.
C.
Are you sure
A
A intersection
intersection
C?
C.
Oh, sorry, intersection. Sorry, intersection.
A intersection C minus B.
Correct. A
Yeah.
intersection C minus B,
B,
because we are
yes.
lefting
Yes.
this particular region. So this is A intersection C.
No, ma'am. B comes with another part of A. There are two sections in A
Yeah,
union
but
B.
if A intersection C you are saying, right? So here this is A intersection C. This whole region, including this
Mm.
part too. If you want to say intersection C, But this is A
But
intersection C
how
minus B.
will we define that dot part? Because
See,
dot
I'm
part is
not
divided
writing dot.
into two.
A intersection B intersection C.
This dot point is not there. I was asking what is this shaded portion. So this is
Yes,
A
yes.
intersection C minus B. We are leaving the points in B, which are in B. Okay.
Hmm.
Got it or any confusion?
No.
Okay.
A. This one show.
See, A intersection C will be, so suppose this is your Venn diagram. So this is A, this is C, and this is B. So A intersection C means this whole portion. This
Hmm.
portion also covers some of the parts from the set B,
Hmm.
right?
Yes,
So we are
that's
leaving
it.
this portion. That's why it's A intersection C minus B. Okay.
Hmm.
So and you,
मैम क्या आप एक एग्जांपल तो समझा सकते हैं जो अपर फॉर्मूला है ये थ्री ए ए यूनियन बी यूनियन सी का वो एक न्यूमेरिकल एग्जांपल के थ्रू थोड़ा समझाती
okay. So suppose I'll give you a Venn diagram with some quantities. And then let's try to find out the values.
Instead of B, can we say A intersection B intersection C?
A intersection B means?
Like A intersection C minus A intersection B intersection C. Is it
Yeah,
possible?
that's also, yeah, this is also possible because this region
Okay.
you are minus. So it does not
Yeah.
matter which region, right?
Okay, okay. So it's correct.
Okay. So suppose I will give you this Venn diagram. See, creating Venn diagram is also difficult because you have to take care of all elements. So I'll give you random numbers. So suppose this portion has 11 elements. So now you have to figure out what is what will be the numbers here. 7, 6, 5. Okay. So now if I ask you what will be the cardinality of A intersection B intersection C,
6.
then what will be your answer?
6.
Okay, so I'll give you 3 minutes to think about it. So here numbers, so if 9 is written in this region, so that means there are 9 elements in this particular region, not everywhere. Okay, that is the meaning for me now. So if 9 is written here, that means there are 9 elements in this particular region. So in every region, I have listed some numbers. So using that number, you have to find out which set has what cardinality. Okay, so it's not that difficult. You just have to find out the numbers.
6
A intersection, yeah, correct.
Ma'am,
It's kind of obvious though, because so what is A
middle.
intersection B intersection C is this region, na?
yes ma'am
And 6 is written, so that
6.
means this is
It's given.
6. Now, what is cardinality of A? Can you find out cardinality of A? So that means how many elements are there in A?
9
4.
8 threes are 24 plus 6, 30.
Correct. So see, what is A? So A means this all this portion, right? This all red shaded part.
Hmm.
So that
All
means
the
you have to
numbers.
add all those numbers. That is 9 plus 8 plus 7 plus 6. What is this?
6.
20,
I mean 30, ma'am.
30, na?
I
So
told
cardinality of A
8
is,
threes are means 1 from 9, you add 1 to 7, so it
yeah,
becomes 8 threes are 24 plus 6,
24 and
30.
6 is 30. So cardinality of A is 30. So now find out, now we can find out all cardinalities. What will be cardinality of B?
15.
it is also 30
28, no?
no
Hmm.
30
7
10
plus 6.
Yeah, 28.
10 by 15 plus 6 21 oh sorry yeah
7
15
is this.
plus 13.
Say from 7 you give 1 to 5, it becomes 3 6 are 18 plus 10, 28.
Yeah. Cardinality of C also you can find out 5 plus 11, 6. So it
29.
is also 29. Okay. So I thought 30. So 29. Now what will be cardinality of A intersection B?
29,
I
how
think
madam?
C is
29?
30.
5, 11, 16, and then 6 will be 22, and 8, 30 will be this, no?
30, yeah. 29 you have written, ma'am.
30. Okay.
A
What will
and
be the
B.
cardinality of A intersection B?
13.
13, 1, 3.
1, 3.
Right. So
8,
because
8
7
plus
plus
6.
6, 30.
Okay.
Now B intersection C will be 5 plus
11.
6, 11. Right?
11.
And similarly, C
14.
intersection A will be
14.
8
14.
plus 6.
14.
8 plus 6. So now we can easily find out what is cardinality of A union B union C. Either you can use the formula or you can just guess. Just add all those numbers, you will find it out. But I don't know this formula work here because see, when constructing Venn diagram is also another tricky part. So it is possible that here the number may not match. Okay.
A
Why, madam?
intersection B
It will match,
intersection.
no, whatever it is. Your
So let's
individual
see it
spaces.
will match or not.
Individual spaces only you have given the numbers. So obviously it will match.
Yeah, so yeah, it should match because we are given individual spaces only. So yes, correct. Because ultimately we are doing the same thing. If I have seen you that cardinality of A is 9, then it may not match. But
Yes.
this way it will match. We just have to either we can add all these numbers or we can use this formula to find it out. So what will be the answer?
Ma'am, if A intersection B was not given there, you have written already 6. Then we have to apply the formula you written above, right?
Right. So that means so again, if you want to find out one quantity, you should know every other values in this formula. Then
3
only you
plus
can
3,
apply
6,
that.
7, 8. There are 8 values totally.
Hmm.
So
So
at
this
least
will be
7
Physics.
you should know.
30.
7 values, bro.
Yeah. Minimum 7 values is required.
Correct. Minimum 7 values is required. But
56
also they will give you the values in some verbal way. Okay. So yes. Any other doubt from Venn diagram? You can find the
No.
value here.
So all clear for me.
Okay. So okay. Now let's go to relations. So what is a relation? So for us, a relation is nothing but a subset of Cartesian product. So suppose I have two sets A and B. I'll define the Cartesian product of these two sets, and any subset of this Cartesian product will I'll say that this will be a relation to me. So any subset. I'm not telling you have to take a particular subset. Any subset of this Cartesian product is known to be a relation. Now there are several types of relations. So we'll discuss main three relations. So first one is the reflexive relation. So reflexive relation means that every element of A should be related to itself. So this is the statement. So suppose I have a relation. So suppose R is a relation on A cross A, or you can take A cross B too. So let's take it A cross B. So suppose I have a relation on A cross B, then R is said to be reflexive. Then R is reflexive if this condition is true, and that condition is for all A belongs to A, this particular pair A comma A should be a part of relation R. Or we can also write as this same thing as A should be related to A. Okay, so either A should be related to A or this pair A comma A should belongs to R. So if this condition is true for all A belongs to A, then we can say that relation is a reflexive relation. Okay, so I'll repeat again. So suppose you have a relation, then that relation is known to be a reflexive relation if for all A belongs to A, the reflexive pair means A comma A type of pair. So if this type of pair is there in your relation, again we are treating relation as a subset of a set, right? So this will be a set. So if this type of elements are there in this relation set, then we will say R is a reflexive relation. Okay, so for example, I'll take suppose you have a relation on a set of natural numbers. So suppose R is nothing but all pairs x comma y such a way that x plus y is equals to 3. Okay, and here this is a relation on set of natural numbers. Then what do you think? Is it a reflexive relation?
Oh,
Is it a reflexive relation?
No.
Why it is not a reflexive relation? Any counter example?
For example, if we take one make
1
one
plus 1 and
Correct.
2 we take.
one and two and
Yeah, we don't need to take 1 and 2. See, reflexive means either 1 comma 1 should be there or 2 comma 2 should be there,
yes, ma'am.
right?
Yes.
Reflexive
Yes,
pair
ma'am.
should be there.
When we take
So they are
same
so when we take
when
the
we take
same
same
number, it will again be a even number. So there is no possibility of taking any natural number and add it with the same number and get an odd number 3, right? So that means it is not a reflexive relation, not a reflexive relation.
Ma'am, if
Because
x plus y is equal to 4, then it must
still it
be
is not a reflexive relation because there will be so many pairs. For example, if you take instead of 3, if you take 4 here, the pair 1 comma 1 is not there, right? 1 comma 1 is not a part of R because 1 plus 1 is equals to 2, so it's not equal to 4. So that means it is not satisfying this condition. So that's why 1
so.
comma 1 cannot belong to this set.
So
So
what we
no,
can
not
put
a reflexive.
instead of 4, so it could be reflexive.
So yeah, here you cannot take any number to become it reflexive because addition of two numbers.
Addition
So vary.
and subtraction too.
Subtraction 2, even multiplication 2.
Only in division we can make. Okay.
In division also, if that is equal to 1, then only. So for
Maybe.
example, so suppose I'll give you a relation R with x comma y. You have to collect all those pairs such a way. Again, x comma y belongs to natural number with the condition that x by y is equals to 1. Okay, and here obviously
Now we
y
can.
not equals to or you can take x comma y not equals to 0. Okay, so now is
X
this a
must be given
reflexive
in
relation?
question. What are the x?
yes, basically, ma'am.
Yes, so obviously it will be a reflexive relation because if you take any x comma x, obviously x by x will always equal to 1. So that means any pair x comma x belongs to R. So that means all reflexive
Okay.
pairs are there. So that's why it's a reflexive relation. So that's why we have to, that's how we have to check the reflexivity of any relation. Okay, so just give me a second. So okay, so that means this first one is not a reflexive relation. The second one is the reflexive relation.
Ma'am,
Yes, Asha.
so for reflexivity, there it is a must that all identity pairs should be there.
Correct. It is a must condition.
It is a must, and it
Yes.
is okay if there is other pairs also.
Yeah, correct. So for example, I'll take another example. So suppose A is containing of 1 to 4, and
It's not visible, ma'am. Sorry to interrupt, but you ma'am.
my screen is visible to everyone.
Yes,
Visible, visible.
Yes,
It is
ma'am.
visible, madam.
Loud
Just
and
check
clear.
your internet. Okay. So suppose I'll give you a relation R with these pairs. 1 comma 1 is there, 4 comma 2 is there, 2 comma 2 is there, 4 comma 1 is there, and 4 comma 4 is there. Okay. So now is it a reflexive relation?
Yes, madam.
No,
No.
because 2 comma
Yes.
2, 3 comma 3 is not there. Oh, it's there. Okay.
So 1
Yeah.
comma 1 is there, 2 comma 2 is also there, and 4 comma 4 is also there.
Yes.
Yeah,
That
it
means
is
yes, it is a reflexive relation.
Yes.
Okay.
So basically, ma'am, every element needs to have like for like 1, 2, and 4, we need to have that a comma a fulfilled.
Correct. For all elements, we need to have this a comma a pair in our relation.
If any of the one is absent, like if
Then
4 and
it's
4
not a
comma 4 is
reflexive relation.
okay, ma'am.
Anyone. So suppose if I remove this 4 comma 4 from this relation, it won't be a reflexive relation. Okay, so what happened? Sometimes relation are given in this format. So that means there will be one condition which tells you which elements you have to consider in your relation. So in that case, you have to just observe the expression and try to find out either a counter example or try to find out such type of argument that okay, if you take any pair x comma x, or if you take any x, then this type of relation, this type of condition should be there, that x by x is equals to 1, so that means x is related to x. So let's take another, so I'll take another example in another type of relations. Okay, so let's go to the second time. Is there any doubt in reflexivity still?
No.
No, ma'am.
Okay.
All
No,
clear.
madam.
Second is symmetric relation. Okay, so again, suppose you have a relation R on A cross B, then this relation is said to be symmetric if for any pair, so for any existing pair A comma B belongs to R. So here what we have to do in reflexivity, we have to check pairs from A. So that means for any element of A comma A type of pair should be there. But in symmetricity and transitivity, we have to particularly look the relation. So for example, if this type of pair is there, so that means any pair is there in R, you have to check that it's reflexive pair, it's symmetric pair. Symmetric pair means B comma A should be there in R. So if this is true for all A comma B belongs to R, then R is a symmetric relation. Okay, so that means for every pair, a symmetric pair should be there. So that means if A comma B belongs to R, then B comma A should be there for every A and B. Then we can say it is a symmetric relation. Okay, so let's try to understand my example. So suppose I'll take A to be again 1 to 4. I'll take R to be as 1 comma 1, 1 comma 2, 2 comma 4, 4 comma 2, and 4 comma 4. So now is this a symmetric relation?
No, ma'am.
Is this a
2 comma 1 is not there.
no, correct, because 1 comma 2 is not there. 2
Yeah.
comma 1 is not there. So
Yeah.
this pair has a symmetric pair which is itself. This pair has a symmetric pair 4 comma 2, but 4 comma 4 also has a symmetric pair itself. But this pair 1 comma 2 does not have a symmetric pair. That's why it's not a symmetric relation. Now observe the last relation we have seen. So suppose R is a relation on natural number with all x comma y, such that you can take real numbers too, doesn't matter. That we have to so we are defining a relation in this way. So two elements x comma y will belongs to R if their summation is some number. You can take any number, so let's take it to be 3, or you can take any number here, so let's take it to be 10. So suppose this relation is there. Now is it a symmetric relation?
Yes, ma'am.
Yes, madam.
Yes, yes.
Correct. And how we can prove it? So suppose we have an element in our relation x comma y. So if x comma y is a part of relation, that means x plus y is equals to 10. But if x plus y is equals to 10, we know that y plus x is also 10. And we can say that, okay, y comma x is also a part of R. So that's how you can argue to say that, yes, this is a symmetric relation. Okay. So that means
But
this is
we
a
don't
symmetric relation.
given the value of x and y, right?
Yeah, so that means this whole steps are true for any real number.
Hmm.
Right?
It could
That's
be
how we
anything.
prove. So whenever you want to claim some property, you have to go with x and y only. You cannot just take particular values and say, okay, for these values the statement is true, that's why it's true. You have to work with x and y only. So because here in these steps, I can substitute any value of x and y. Still these steps will work. Correct? Okay.
Yes, ma'am.
So now is there any doubt in symmetricity? Symmetricity is kind of obvious. If A comma B is there, you need to check B comma A is there or not. Then it's a symmetric relation.
Suppose we have a set A 1, 2, and 4, and I
Okay.
want to ask in this set,
Hmm.
yeah, 1 comma 1, 2 comma 2, and 4 comma 4. It will be symmetric or not?
Yes, it will be symmetric. Why it will be symmetric? Because the symmetric pair for 1 comma 1 is 1 comma 1 only, and it is already there. For 2 comma 2, the symmetric pair is 2 comma 2 only, and it is already there. So we know that in a set we do not repeat an element. So we write an element only once. So if 1 comma 1 is there, you can assume that it is its own symmetric pair. Okay. So here for every pair, the symmetric pair is there. So you can immediately say that, okay, this will
And
be a
this could be
symmetric
also
relation.
reflexive, right?
Sorry, what?
And this pair can be reflexive also.
Yeah, this is a reflexive relation.
But the definition of symmetric relation is A comma B and B comma C, but how it is not present here. A comma B and B comma A.
It is
Yeah, but
present. 2 comma 2
A
or 2
comma
comma
B,
2 is all the
2
same, right?
comma 2 and 2 comma 2 is there. But we don't write. So suppose you will write this set is same as this set, right? I can write 1 comma 1, 1 comma 1, and then 2 comma 2 and 2 comma 2. But we know we don't repeat elements in the set. So that's why you
Yes.
can assume that,
That's
okay,
we are
these are
imagining there is
20s.
another set.
Yeah.
Okay.
So ultimately, we do not repeat elements in the set. That's why we assume that, okay, since 1 comma 1 is there, it is its own symmetric pair. Okay, is that fine?
Yes, ma'am.
Okay. So now let's go to transitive relations. So in transitivity, we have to check one more condition. So in
For this
reflexivity,
same concept, question also came in exam. Can you see in chat?
yes. Just one second. Yes, this type of question can be in exam. That means here
Yeah.
reflexivity is
R2 is
asymmetric.
symmetric.
How? R2 is symmetric. Yes, because again, the same symmetric pairs are there. Jan comma Jan is there. So everyone can see the question pasted in the chat. Okay. So just click on the question and see. Jan and Jan, this pair is there. Feb and Feb is there. March and March is there. So all symmetric pairs are there. So whatever pair is there, it's symmetric pair. It's so itself. I mean, so R is something month's name. So Jan comma Jan is there. So this pair's symmetric pair is itself only. So that means Jan comma Jan. So that's why it is a symmetric relation.
And ma'am, this is also reflexive.
This is also reflexive because for every
And 1-2 function, 1-to-1 only.
yeah, so we'll come to functions too, that how we can relate the functions and relations. So yes, it is a one function. It is also a onto function because it's just an identity. We are mapping the same element to same element. Okay.
Ma'am, can
Thank
we
you.
say that R1 is not neither reflexive nor symmetric?
So R1 is Feb, March, April. So it is not reflexive because Jan comma Jan is not there. March comma March is also not there. April comma April is not there. So there are so many missing pairs. So he is obviously not reflexive. I'm talking about R1. So R1 is obviously not reflexive. And about symmetricity, so let's check. Feb comma Feb's symmetric pair will be Feb comma Feb only. March April symmetric pair is April comma March, which is already there. And March symmetric pairs is March comma March is only, and this is also there. So that means R1 is symmetric. You have to check pair by pair. So for every pair, its symmetric pair should be there. And if it's the identity pairs, that means A comma A type of pair, then its symmetric pair is itself A comma A only.
Ma'am, but in R1, Jan, comma Jan or any combination related to Jan is not fulfilled.
Yeah,
So
correct.
then
But
also
we
we'll say it's symmetric.
Yeah. So that's the thing. So when we check for symmetricity, we just have to look pairs inside the relation. We don't have to go with the set. We have to check this condition if A comma B belongs to R. So that means we have to concentrate on those pairs which are inside our relation. We don't have to worry about sets element. So whatever element is there in set, we don't want those pair to come here. But we want all those pair which is already inside the relation if those pairs has a symmetric pair or not. You're getting my point? We don't have to go outside of our relation, our given relation. So we just have to check all those pairs which are already in our relation. So for example, here there are 4 pairs. So for 4 pairs, you have to check if symmetric pairs are there or not.
Okay, ma'am.
Is that okay?
Ma'am,
Yes.
Yes.
is R1 transitive?
Yeah, so I'll come to transitive also. So first, let's define what is a transitive relation.
Ma'am, in case of R2, it may would not be there. So it would be reflexive or not?
Sorry, what?
May और may नहीं होता वहाँ पे in R2
हाँ हाँ
relation. So what would
हाँ
be
हाँ
there? Reflexive होता है या नहीं होता?
हाँ नहीं, फिर नहीं होता, क्योंकि हमें रिफ्लेक्सिविटी के लिए हमें सारे ए के लिए चाहिए. फॉर रिफ्लेक्सिविटी वी नीड फॉर ऑल ए,
और
कि फॉर ऑल ए वट एवर इज इन दिस सेट we need that reflexive pair. But for symmetricity, we just have to look the relation. Okay. So let's define what is a transitive relation.
Transitivity.
So transitive relation. So transitive relation means, again, you just have to look the relation. You don't have to look the set. Okay. So suppose you have a relation over some set C comma B. So here you have to understand the statement. So if part is, you have to first find these kind of pair. A comma B belongs to R and B comma C belongs to R. So if you find such a pair, then you have to check something. If you are not able to find such a pair, then you don't need to check anything. Then you can vacuously say, since there is nothing to say that transitivity is false, we can automatically say this relation is transitive. So I'll explain this one also. So the condition is,
Ma'am, if
yeah,
in transitivity A, B, C are there, no?
A comma B belongs to R and B comma C belongs to R.
No,
So then
C
this should
must be
imply
there.
A comma C belongs to R. Okay, so this is the statement we have to check. But here, observe in this statement, there are two parts.
Madam, what is the question was? The
Hmm.
sets A, B only are there. Where is C coming? A cross B we have
Yes.
written, no, ma'am.
Yeah.
So where is that C coming from? Is asking.
Oh, okay. So see, here the small letters are the elements. Okay. So A, B, C either belongs to A or in the set B. So we are taking pairs from A cross B. Okay. So these are the pairs. Pairs from Cartesian product, right? First elements comes from capital A, second elements come from capital B. Again, first elements comes from capital A, second elements come from capital B. Is that okay? This is the question? Okay.
Yes, ma'am, this is okay, but I am
Hmm.
saying A
Hmm.
and B is there, right?
Hmm.
So it must be C somewhere in element R, so it came into R.
It is. See, I'll give you an example for this.
Or
So
it must
suppose
be A, B, C are the element of R, then A and C is equal to R.
so yeah. So let's see here. So 1 and 2 is there. 2 comma 4 is there. 4 comma 1 is there, and 1 comma 4 is there. And suppose 2 comma 3 is there. So suppose this is the one type of relation I have given to you. So now here, what is happening? We have to find out such a pair, A comma B and B comma C type of pair. Okay, so here B should be there in both of the pairs. B should be at the second position in this pair and should be over the first position in this pair. So here, if you consider this to be your A, this to be your B, you have to find a pair with 2 at the first position. So this is one pair, this is another pair. So here we have two type of transitive pairs. So if you consider 1 comma 2, so 1 comma 2 belongs to R, 2 comma 4 belongs to R. So now what you have to check? You have to check that transitive pair. That means 1 comma 4 is there in R or not. Okay, so this is what you have to check now. So it's there in R. So it means 1 comma 4 is there in R. Now there is another transitive pair, that is 2 comma 3. So that means 1 comma 2 is there in R and 2 comma 3 is there in R. Now you have to check that 1 comma 3 is there
1,3.
in R. So, but 1 comma 3 is not there in R.
Not there.
So now you can say that it's not a transitive relation.
There is also another pair, no? 4 comma 1 and 1 comma 4.
Yes, correct. 4 comma 1 is there. 1 comma 4 is there. 4 comma 1 is there, but
1,1
1
is
comma
not
1 is
there.
not there. So yes, it is not a transitive relation. So this is one scenario where you are getting
2
such a
comma
pair.
also is
Yes,
there. 2 comma even one pair is not satisfying, then it is not transitive.
correct. 2 comma 4, 4 comma 1 is also there. Correct.
So
So
if
there
there
are,
All pairs
are six
should
pairs,
satisfy.
if there are
sorry, what?
five pairs in, madam, if there are
Hmm.
five pairs in a
Hmm.
relation, given relation,
Hmm.
how many such
Hmm.
combination is possible?
It depends on the values. So, for example, I can take 5 pair with distinct values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there is no transitive pair, correct?
No, for how many pairs
It
we have to
depends
check?
on
Like
the
all the 10 pairs we have to,
values.
all the five pairs we have to check, madam, for checking.
Right, right,
First
right.
you took
Correct.
the first zeroth one, 1 comma 2, you A
Uh-huh.
comma B, 1 comma 2. Then you
Yeah.
saw where all 2 are there. So it is
Hmm.
there in 2 comma 4 and 2 comma 3.
Hmm.
So since
Yeah.
2 comma 4 is there, we are checking for 1 comma 4.
Yeah, these 2 pairs. Yeah, so
Yeah. So
in this
like
way,
this,
you have to check for every pair.
yeah, every pair. So you start with the zeroth element
One
or
pair.
the 1 comma 2 and check for all the 4.
Hmm.
If it is available, then check for the B comma C comma A comma C.
A comma C
Then
pair.
you go to the second one. For
Second
second one, you have to check the next three or even the before one also, madam. Like 2 comma 4 is there.
one. Before
Here
one
2 is
also,
not
because
there.
it is
So we can,
possible that before one also, it is possible to get one here.
yeah,
Hmm.
yeah.
So before
Okay.
one also. Okay.
Yeah.
So,
Similarly, for example, 4 comma 1 is
hmm.
there means you have 2 comma 4. So 4 comma 2 should be there like that.
Correct, correct.
So yes,
So,
4
yeah.
comma 2 is not there.
4 comma 2 is not there. So 2 comma
So
4 is there, but 4 comma 2 is not there. So you have to check pair to pair. If you are getting transitive pair, if you are getting this kind of condition, you have to check it for every pair. Okay, A comma B
so for
and
5 comma 5 pairs are there, you check for each pair 4 times. So 5
hmm,
for the 20 times you have to check.
yeah, right.
Yeah, that was
Okay.
my question.
Excuse me, ma'am.
Yes, yes.
Ma'am, for example, in the above example,
Hmm.
what element we have to include this relation for the relation becomes
Transitive, right?
transitive, right?
Yeah.
Yeah.
So here there are so many pairs are missing. For example, 1 comma 4 is missing, 1 comma 3 is missing. Now we just observe 4 comma 2 is also missing. So you have to check which pair is not there, and then you can include those pair and make it transitive. So there are more than 3 pairs which are absent here. So 1 comma 3 is also not there. That is
Ma'am,
what
please
we figure
describe
it
one
out.
by one, please. Please describe one by one, please.
So I was telling there are so many pairs. You just have to take and whatever pair is not there, include it. So for example, here I take this statement. I got that okay, I need 1 comma 3 in my relation. So I'll include 1 comma 3. And after including 1 comma 3 also, you have to check for another pairs too. Because see, if I include in relation R 1 comma 3, there is another pair with okay, there is no pair with starting 3, but there is pair with starting 2 comma 3. So if I include 1 comma 3, there is another one pair which is 2 comma 3. So here the transitive pair will be 2 comma 3 and 1 comma 3. So this won't give us another transitive pair. So the answer to your question is just check for each and every pair. Whatever pair is not there in R, then include it. Okay, then you can make it transitive. So there are a lot of
Ma'am,
pairs here.
ma'am, then in this example, r equal to 1 comma 2, 2 comma 4, 4 comma 1, 1 comma 4, 2 comma 3. There are two pairs, एक मिनट ma'am. Yeah,
Hmm.
2 comma 4 and 4 comma 1. Okay.
Hmm.
Then 2 comma 1 also be in the relation
Correct. 2 comma
transitive.
1 should be in a relation if you want it to be transitive.
I mean, we have to check before and after that
Adding
particular
the
element.
pair to.
Okay, ma'am. Thank you.
Okay. So this is one type of check. But suppose I'll give you this relation. Suppose this is R. 1 comma 2. Suppose I'll take any set E with 10 elements. So suppose I'll take 1 up to 10. Okay. So this relation is 1 comma 2, 3 comma 4, 5 comma 6, 7 comma 8. So suppose this is a relation. Now what can you say? Is it transitive?
Yes, ma'am. Obviously.
Yes, because there is nothing to check. There is nothing to check. Like we don't have such kind of pairs, A comma B and B comma C. So when there is nothing to check, we vacuously or trivially say, since there is nothing to contradict our definition, yes, it is a transitive relation. Okay.
In
Is that
in
clear?
In other words, to prove it is not a transitive, you should find a pair such that A comma B and B comma C are there,
E-commerce.
but A comma C is not there.
Correct, correct.
So here A comma B and B comma C is not there first of all. So we can always say, you cannot say it as not transitive, so it is transitive.
It is transitive relation. Correct. So this is simple check. Now there is so is there any doubt in transitivity still? Anything which is not clear?
No, ma'am. No, ma'am. Everything clear.
Okay.
But
So now,
transitivity,
Mhm.
word problem, like we had that in graded assignment, no? That was one issue was there, madam. Anyway, we explained it, but once again, if we can do some word problem, any previous question papers or something like that.
word problem means do you have any
Yeah,
particular
even in
problem?
our own graded assignment only, it was there, no, madam.
Uh,
Lake problem.
let me check. Uh, week 1 graded assignment, no?
Yes, ma'am. Week 1 graded assignment question number 5, I.
So there is much content in week 1. So week 2 is just equation of line. So there you just have to remember the formulas. The concept is also there, but concept is not. Question number 5. 5. Which question can you see the starting of the question?
A survey was conducted.
I posted in chat box, ma'am, also. You can see.
Yeah, thank you. It will be better. Okay, this question that a survey was conducted on a pollution of 225 pounds acres, some city. It found that 230 pounds are polluted by fertilizer F, 245 pounds are polluted by pesticides, 257 pounds are polluted by pharmaceutical products, 100 pounds are polluted by pesticides. And okay, so this is okay. So now what is there? So define a relation on the set of 225 pounds such that 2 points are related if both are polluted by fertilizers and pharmaceutical products. So which of the following is are true? Okay. So what you have to do? You have to check here the reflexivity and transitivity. Okay. So the relation R is the relation on some 525 points. So 2 points. So suppose I'll name those 2 points. So suppose there are 2 points A and B. Then they are saying that these 2 points are related. That means these 2 points are a part of relation. If both are polluted by fertilizers and pharmaceutical products. Okay, so that means if 2 points are related, if both are polluted by pharmaceuticals and fertilizers. So first question is it a reflexive relation? Okay, so reflexive
Ma'am,
relation
excuse
says,
me.
sorry, what?
Excuse me, ma'am. Sorry to interrupt, but I think please elaborate the question because I couldn't understand
Okay,
question.
fine. So here's the chat here. So see, the question is something like this. I think you guys can see. So a survey was conducted, and there are on 225 ponds. So suppose you live in a city where there are 525 ponds. Ponds means small lakes, you can say, across the city. And it was found that from among these ponds, some ponds are polluted, but they are polluted by some particular substance, for example fertilizer or pesticides or pharmaceutical product. So they have distributed these ponds over the pollutant. For example, if there is a pond, suppose there is a pond, name that pond to be A. So if that pond is uh, what you can say polluted by fertilizer, they counted that as one in this set capital F. Okay, so this is Venn diagram is given to us. So in this Venn diagram, this set F means ponds polluted by fertilizers, P means ponds polluted by pesticides, and pH means ponds polluted by pharmaceutical waste. And it's given that 230 pounds are polluted by first pesticides, right? Sorry, fertilizer. So that means cardinality of F is given to be 230, cardinality of P is given to be 245, and cardinality of pH is given to be 257. Okay, so this is the cardinality given to us. But with this, some additional information is also given to us. So additional information is 100 ponds are polluted by fertilizers and pesticides. So that means cardinality of F intersection P is given to be 100. Cardinality of F intersection with pH is given to be, because there are 82 ponds are polluted by fertilizers and pharmaceutical product. Okay, fertilizer and pharmaceutical product. So and means intersection. So F intersection with pH is given to be 82, and then 77 ponds are polluted by pesticides and pharmaceutical products. So that means pesticide intersection with pharmaceutical product is actually equals to 77. So this is the information given to us in a question. And now they say that if we define a relation, so how they are relating? So they are relating which? What quantities they are relating? They are relating two ponds. So if you have two ponds, then these 2 ponds are related if both of them are polluted by fertilizers and pharmaceutical product. If both of them, not one. That means the pond number A should be polluted by fertilizers and pharmaceutical products, as well as pond B should be polluted by fertilizers and pharmaceutical products. Okay, so if in both ponds, if you find these two substances, you can say that they are polluted by these two products. Now this is the relation they are defining. So now over this relation, they are asking some question. So one question is this relation is reflexive? Okay. So here, what is a set? On which set we are defining the relation? So we are defining the relation on the set of ponds, and there are 525 ponds are given to us. Okay. So among these ponds, can we say that each and every pond is polluted by fertilizers and pharmaceutical products? Can we say that all 225 ponds are polluted by pharmaceutical and pesticides of
No,
fertilizer? No,
we
right?
cannot say.
We cannot say, because ponds which are polluted by these two substances are only 82. It's given to us that
Yes.
F intersection pH is 82. So that means only 82 ponds are there which are polluted by both of the products. So that means there are ponds which are not polluted by both of the products. So we can say yes, there are pairs A comma B with A comma A which are not in relation R. Okay, so there are some pairs which are A comma A for which A comma A is not in our R. So with this will give us a contradict our
Pardon, could you
definition of
please repeat?
reflexive. Sorry, what?
Please repeat, please.
Yeah, I'll repeat. So the relation is defined on ponds. So that means two ponds are related if they are polluted by fertilizers and pharmaceutical products. Okay. So now it's given in the question that cardinality of F intersection pH is 82, which means that ponds which are polluted by pharmaceuticals and the fertilizers are only 82 among 525. So that means there will be some ponds which are not polluted by fertilizers and the pharmaceutical products. So that means if these ponds are not related to themselves, right? So we know that A comma A is related only both are polluted by, but here we are not talking about both. Here we are taking the same ponds. Okay. So that means it says that if you want this relation to be reflexive, all 520 ponds should be polluted by fertilizers and pharmaceutical products. Okay. But since there are only 82, there will be some ponds which are not polluted. So we can say it is not a reflexive relation. Is that clear?
Yes, ma'am.
Thank
Clear.
Yes,
Okay.
correct.
thank you,
So
ma'am.
if not, just think about the relation. Okay. So now the second one is it a symmetric relation? Okay. So just work with the relation. So relation says two ponds are polluted if both are two ponds are related if both are polluted by these two substances. So now what do we do for symmetricity? So assume. So suppose A comma B are two ponds and they are related. Okay. So if A comma B are related, that means both are ponds and both are polluted by fertilizers and pharmaceutical products. So we can immediately say that okay, B comma is also related because again both are ponds and both are polluted by fertilizers, pharmaceutical products, right? Because here
Yes, ma'am.
given statement is like this. If A comma B is related, then we can imply that B comma A also related. So that means yes, it is a symmetric relation. Is that clear why it is a symmetric relation?
Yes, ma'am.
Because of the wordings, right? Now let's go to transitivity.
For reflexivity, you have taken the total 525 points. But
Correct.
for symmetricity, you have taken only the 82 points. But the relation
Uh,
is only
yeah,
for 82 points only, no?
right. Because on symmetricity, we just have to look the relation.
Okay, why reflexivity you take total 525 points?
Because for reflexivity, we have to check this statement, right? That for
No, the
all.
relation 525
Huh.
points is the set, but the relation is only for a fertilizer and pharmaceutical only, no?
Correct.
Relation has only 82.
82 or
525 overall
82
set.
cross 82.
We have to check the reflexivity also on 82 only. Am I right?
Yeah, so I cannot say 82 because this is a number of ponds which are polluted. So it means
Yeah.
82 by 82,
The
something like that.
relation is for both the
Both ponds should be polluted by fertilizer and
fertilizer and
pharmaceutical. Mhm. Okay, so similarly, we can check transitivity too. So suppose you have some transitive pair. So if there are no transitive pair, then that's okay. But suppose we have some transitive pair. So suppose A comma B belongs to R and B comma C belongs to R. So now what does this mean? This particular thing that if A comma B belongs to R and B comma C belongs to R. This means that the pond A is also polluted by
Both
fertilizers and
fertilizer, pharmaceutical.
pond B is also polluted by fertilizer and pharmaceuticals. Pond C is also polluted by pharmaceuticals and fertilizers, right? So we can say that okay, pond A and pond C is also polluted by pharmaceutical and fertilizer. This pair A comma C should be a part of R, right?
Yes,
So
ma'am.
we assume A comma and B comma C belongs to R and prove it A comma C belongs to R, which will
Yes,
imply
ma'am.
that
Yes.
our relation R is transitive.
Yes, ma'am. Clear, ma'am. Thank you, ma'am.
Okay, so this is a good example. Now let's go to the next topic. One thing is mod. So whenever you see mod, so mod means
Ma'am,
mod is just a yes.
I've also doubted a question.
You have sent another. You have doubt in what?
Okay, I'm sending.
Okay. So see what is mod. So mod is another way of saying of giving the information about the remainder. So for example, if you divide B by A and C is the remainder, then we can write that okay that B mod A is actually equal to C. Okay, so this is a fancier way to write the remainder. So mod is nothing, but if you write if you divide a quantity by another quantity, whatever remainder you will get, that will be your mod. Okay. Now suppose I'll define a relation R here. R says collect all those natural numbers x comma y belongs to natural numbers such that x modulo y is sorry. Okay, so we can I think you guys have this type of example. So there is one more question. Okay, so So I'll come to this question at the end. Okay, is that fine, Alok?
Sure, ma'am. Sure.
So about relation, that's all. I think I have covered major type of relation. About modulus, you can find some examples in your practice assignment. But let's see. Now let's go to function. So what is a function? So a function is nothing but a map from a set A to a set B. So suppose you have a map from a set A to a set B. So suppose F is a map or a correspondence or a rule, whatever you want to say, you can say. So suppose F is a map from a set A to another set B with two conditions. Right? With two conditions. So those two conditions are for every A in A, there is a unique B in B. B in B, such a way F is taking A as an input and giving us B as an output. Okay, so this is the definition of function. So the function definition follows two important points. One is every. So that means every element of the domain should get mapped, and it should get mapped to a unique element of codomain. So this every and unique word should be satisfied by that particular map. Then such type of map are known to be a function. Now again, functions can be expressed as a relation. So that means for any function, you can have a similar kind of relation. But in this relation, what are the pairs you have to take? You have to take a pairs like a comma f of a type of pairs, where a is your point from the domain. Okay, so that means it is possible to express function in terms of relation, and we can say that a function is also a relation. So this statement is true, that a function is a relation. Okay, but the converse is not true. That means every relation need not to be a function. So every function is a relation, but every relation need not to be a function. So I'll explain the example too. But here first understand how we are defining the relation. So suppose if you have a function f, so then for this function we are defining a relation Rf. So in this relation we are containing some pairs. But in those pairs, how we are taking? So we are taking A to be our input and f of A as our second coordinate of this pair. So one is the first is input, second one is the output. So that's how we can say that a function is a relation. Okay. Any doubt?
No,
Ma'am,
no,
I
I
beg
don't
your pardon.
understand.
Please, could you explain once more the function?
Yes,
Yeah.
yes. Good.
So see, a function is what? So you have some map from a set to another set. But this map should satisfy two conditions. First condition is every element of this set should get mapped to somewhere. Okay. But that mapping should be unique. For example, if I take this example, so suppose I have a map F from a set A to another set B, such that set A contain 4 elements, set B contain 3 elements, where 1 is going to A, 2 is going to B, 2 is also going to B, 2 is going to A, 2 is going to B, 3 is going to C. Now can you say, is this a function?
No, ma'am.
No.
Right. Because here every is also not there and unique is also not there. Every,
Ma'am,
since 4
4
is
is
not
also
getting
not
mapped,
4 is not mapped, so it is
correct.
not a
And this 2 is also get mapped to more than one images, right? More than our one outputs we are getting. So this is not a function.
So
Okay.
by unique you mean that each element will get
One
one
output.
image,
One
or
image.
one output. I
Right.
understood. Okay, okay.
Okay.
Thanks, ma'am.
So this is the one thing. Now suppose, yes. Anything else? Okay.
Ma'am,
Now suppose
please
I'll
could you explain, please, what's the meaning of a comma f of a?
A comma f of A. See,
Yep.
I'm saying that for any function, we can express this function as a relation to. And for giving a relation, what is a relation? Relation means a subset of Cartesian product. So for creating a subset of Cartesian product, we need to define such a pairs, right? A comma B type of pair. So but here A comma B type of pair, so A will be your input and B you have to take as an output. For example,
So
if I give, yeah,
B is the function of A. I
right.
understand.
So for example, here, if I say this is our new function. So suppose 2 is mapped to A, 3 is mapped to, and suppose 4 is mapped to B. So now this is a function because every is satisfied, unique is also there, right? So for this function, I can also define a relation RF. What I'll do, I'll have to contain the pairs, but in pairs, first will be your input. So here we have 4 inputs. So that means 1 is there, 2 is there, 3 is there, and 4 is there. And over the second coordinate, I have to list out what is the output related to each and every element. So 1 is mapping to A, so I'll write A here. 2 is mapped to A, so I'll write A here. 3 is mapped to C, and 4 is mapped to B. Okay, so this function also can express as this particular relation. Okay, is that okay now? How
Yes, ma'am.
we can express function as a relation?
Yes,
Now
ma'am.
there are another way to expressing a function also. So one is the particular equation you can give. For example, f of x is equals to x square or x cube. This is another way for expressing a function. One more
And do you
way
have
is
another method for the
another method means you can express a function like this x square x cube given some equation. Another one is just by giving a graph. So a graph also represents a function, but there is also one thing that which graph represents a function or not. For that we'll use vertical line test. Okay,
this is complicated. Use
which one?
this one only. Have lines A, B, and 2 to A.
Yeah, so here I'm just creating a function. So 1 is get mapped to A, 2 is get mapped to A, 3 is get mapped to B, 4 is getting mapped to C. Something like this. Okay, so let's take another example. So I'll give you one relation. Now let me know if this relation represents a function or not. Okay, so suppose I'm taking all x comma y, where x and y are your real numbers now, and x is strictly greater than y. Now is this a function? Is this relation represents a function? Or simply you can say, is this a function or not? So what can you say?
It seems it's not a function.
Not a
For
function because
x
x is greater than y. Any number it can map. X can map to y.
equal to
Correct. There is no uniqueness here for input and output. If you take
Yes,
x in
because
input, you can get any output, right?
it must be equal to greater than or equal to.
Correct. So for example, if I take 1 as an input, you can take 0 as an output to 1 as an input, you can take -1 as an output to. So that means there is no uniqueness here.
Getting the answers.
So that means this is not a function. Okay, now suppose I'll give r as x comma y, such a way x comma y belongs to r, and x plus y is equals to 5. Now is this a function?
This could be.
Yes.
Correct. Well, this is nothing but the equation of line, right?
Line.
This is
Linear
representing a
equation.
line. And we know that a line is a function. So yes, it is a function.
yes,
So
ma'am.
that's how you can just observing the
आंसर आ जा रहा है बट
input.
समझ नहीं आया अभी.
See, here what is happening? The relation is given in this way, that x plus y should be equal to 5. That means x and y are related if x plus y is equals to 5, right? So what you can say that, okay, if x
2
plus
plus
y is
3.
equals to 5, y is equals to 5 minus x. Okay, so now
हाँ.
here for function you need to check two words, every and unique. Okay, so is every is there? So yes, every is there because for any real number x, I can find another real number 5 minus x, and that will be my output, right? If you take x as an input, you will get 5 minus x as an output, and this is a real number. There is no worries, right? 5 minus x we are doing. So that means every word is there. For any real number, I'll have an output, right? For every real number, we have an output. Now, the second word is unique. So unique is also there because if you change x, 5 minus x will also change, correct? So that means if you fix an x, you will get a fixed 5 minus x. So that means for a unique input, or for an input, we have a unique output. For an input, we have a unique output.
Ma'am, unique output in the sense that the output should not have two inputs.
No, this is possible that an output can have two inputs, but a input should not get mapped to two distinct outputs.
Okay,
So for example, if you fix x, you surely know what is your output is.
Yes.
Okay. So here if you fix x, you'll get a fixed output, 5 minus x. So yes, unique is also there. So that means yes, it is a function. Okay. And another way is thinking like, okay, since it's an equation of line is a function. So you can say it is a function. Okay. 1-to-1 is a little different. So 1-to-1 means two distinct inputs get mapped to two distinct outputs. So here I'll justify this by a picture. So function. So in function, what we want if you have an input, it should get mapped to a single output. Right? This is the thing we want. We don't want this type of thing. That an input getting mapped to two distinct output. This we don't want in function. But in 1-1 function, what we are treating, we are taking two distinct inputs and we want these two distinct inputs to get mapped to two distinct outputs. Okay. So distinct inputs x1, x2 get mapped to distinct output f of x1 not equals to f of x2. This is an 1-1 function. Okay. So we don't want 1-1 function like this. That means x1 not equals to x2, but f of x1 is equals to f of x2. This we
This is
don't want
on2.
in 1-1
Yeah.
function. Right?
This is
Sorry, what?
on2, no, ma'am. This is on2.
Which one? No, this is 1-1.
Second, ma'am. Second.
This one?
One
Yes,
he's
ma'am.
asking.
Yeah.
Yes,
So
ma'am.
see, this means this condition we don't want in 1-1 function. That
Why
for distinct
on2, ma'am?
inputs.
On2. I mean, meaning
No,
well.
no, no. It's not onto.
We're
Onto
explaining
is different.
into.
Yeah, into you can say, but we don't define those terms like into, many to one.
Ma'am, it is many one, na? Yeah, many one.
Yeah, these terms we don't define in our course because they are little confusing. Also, they won't applicable much.
Okay, ma'am.
There are no use of these terms. So let's stick to 1-1 only. So you know 1-1, you know onto. That's all. Okay. So this is a one thing, and the last one is vertical line test. Okay. Line test for functions. So what you have to do, as I told you, that a function can be expressed as a graph. So if a graph is given to you, then how you can judge that graph represents a function or not. So what you will do, so suppose a graph is given to you, then what you will do, you'll draw several vertical lines. Several vertical lines. Okay, vertical lines means those lines which are parallel to y-axis. Okay, so what you'll do, you'll draw several vertical lines, and if there is a line which intersect the graph more than once, then that graph does not represent a function. Okay, and why is this so? I'll also explain. So the result says if there is a vertical line which cuts or intersects the graph more than once, then that graph does not represent a function.
But uniqueness fail कर जाता है. We
Correct.
uniqueness is failed.
Uniqueness fail कर जाता है. तो इसलिए, so if you take the graph of a circle, so suppose this is your circle, you need circle, then this graph is not a function. It is not a function. Because here we can draw a vertical line somewhere like, suppose this is a vertical line I can draw, and for this input, for this x0, I'm getting two outputs. Right? Because we know that the points of a graph, the coordinates of a graph look like x0 comma f of x0. Right? Similarly here x0 comma f of x0. So for one input, we are getting two distinct outputs. So this will be something like different. So we can take this part. So that's why vertical line test works if you have a graph and you want to judge that graph represents a function or not. What you'll do, you'll draw several vertical lines, and if you get one vertical line which intersect the graph more than once, then that graph does not represent a function. Okay. Is that okay? Clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So now we left with equation of line. Anything which is not clear in functions relation?
Ma'am, please explain onto function.
Yeah, so on to function. No?
Ma'am, excuse
Yeah.
me.
Hmm.
On-to function, can I summarize and say? Actually,
Yeah, so onto means range should be equal to codomain.
range should be, or we can say that suppose f of x or that b,
Correct.
they are the mapping all should be related to a
Right. So what do you want to say? So either we can simply say that the range of f should be equal to codomain,
codomain.
or we can say that for all b in B, we are able to find, we can find an A in A such a way that this f of A is nothing but B. That means for each B in B, it is possible to get an A in A such that if you
Hello, good morning, good afternoon, good evening, good night. Eh? Thank you very much.
Which of
Please
your
mute
bad?
yourself.
yeah, please, Naren. Not able to
చెప్పండి బాబా,
mute.
28 గంటలు దాని ఇప్పుడు చుట్టి ఫోన్ చేస్తున్నారు పెళ్లి రోజు. ఊరికి అట్లా చెప్తా అండి, బాగున్నది గలాట చేస్తా అంట.
Please mute yourself, Narendra.
Yeah, I've done now. Okay. So onto means for each B in B, if we are able to find an A in A such that f is mapping A to B, then we say it's an onto function. Now again, it's not easy to find out an onto function, but there are some
We can
functions.
say that actually all elements in B are used actually.
Yeah, correct. All elements in B are used or get mapped or has a pre-image. Those words we can use. So for example, it's suppose I have a function f from real number to real number. Simple function f of x is equals to x square. Okay. So now this function is very easy to say. Is it a onto function? F of x is equals to x square?
No, ma'am.
No,
No, right?
0 to
Because we never get negative values.
it doesn't pass what
Right.
horizontal lines.
So here you can use the horizontal lines. So what you will do, you'll find a horizontal line which is not intersecting the graph. So if you are able to find such a horizontal line inside your domain, inside your codomain R, so here -1 belongs to R. So inside your codomain, if you are able to find a horizontal line which is not intersecting the graph, you can say that that function is not an onto function. Okay. But in general, it's very difficult to find out onto. But some functions are very easy to know. For example, this function is not onto. If you take f of x is equals to x cube, is this onto?
Yes, this is on.
Yes, this is onto, because by the graph also you can say, and also by the observation that cube root we have. So for any value, I can find out a unique cube root, and that's easy. Just we have to take the cube root. But in square, we can get a complex number. That's why there the issue happens. For example, -1 under the root if I'll take, then it's not a real number. But here I can take the cube root of -1. That will be a real number. Okay, so yes, this will be a real
What
number.
is cube root of -1? What is the
I
cube
think
root?
it's -1 only.
-1.
F of
-1
x,
cube is also
x
minus.
is equal to 1/2.
So that means negative of cube is defined. Huh?
That's why negative of cube is defined.
Okay.
Ma'am,
It's for inverse function. If your
Hmm.
x cube is there, if you want to calculate the inverse function, ठीक है नहीं तो if I write x raised to power 1/3, then
Right.
then domain of x you can write that is all real number.
Correct. That is all real number. Because we
Oh.
can get complex number only if we have even problem. Because then only under the root of -1 comes in picture. But cube root, fifth root, and all those things, we can find a real number.
Yes. Thank you so much.
ma'am,
Okay.
if in the above example, fx is equal to x square, if we take from real to natural numbers, will it be onto?
Yes, now it will be onto. If you take instead of real number to rational number, because then for any natural number, we have a unique square root. Correct? 0,
Okay,
1,
ma'am.
2, 3. The square root creates problems only when we take negative numbers. But if you consider natural number, then all numbers are positive, so we have a unique square. Okay, so now if you guys are familiar with polynomial, so they can ask or someone can easily interrupt this result that
Excuse me, I had one doubt actually in this part.
yes.
Ma'am, in onto function, how to find by using graph actually, because x cube, that also I couldn't be able to get.
So see, so if I have a function f from real number to real number, x cube simply take f of x is equals to x cube. So now this is the graph of x cube.
Means what's the easiest way to understand?
So here,
This graph only.
see, here it's growing upward infinity. Here it's growing downward towards minus infinity. So no matter whatever value of y you will take, this line always intersect the graph at least at one point. No matter whatever value you will take over y-axis. You can take as large as you want. Suppose I'll take here 10k. Then also it will intersect the graph at once. And once it get intersect, you can find out here input, and here this 10k will be your output. Right? Input will be whatever related value is here. Okay, so if a line is intersecting the graph means this y value can be taken by the function.
Ma'am,
At that input we can get.
4x raised to power 1 by 3. Okay, let me know, ma'am, how will be the
What is this? 4?
x raised to power 1 by 3. X raised to power 1 by 3.
Okay, so okay, so x raised to the power 1 by 3.
Yes, ma'am.
So if you find out the graph of this function, so the graph of this function will look like this. So this is the graph. But ultimately, sorry, I have drawn it wrong. So it increases towards minus infinity, but very
Ma'am,
very small rate.
you are making the image about y equal to x. Yes, ma'am?
Y equal to x line, correct? Because
Yes.
that's how we form the graph of inverse function.
Yes, ma'am.
So here also it's growing towards infinity, but very little rate of change. I mean, very slowly it's growing to infinity. Here also it's growing towards minus infinity, but again very slowly. So
So
that's
it
why,
will be onto.
yes, so it will be onto
1 1 also.
1 1 also.
Yes.
1 1 by horizontal line test, and onto by just you can check, and for any value, any y value, you can get an x value.
It is clear. Thank you so much.
Okay.
So what's the actually easiest way to understand? Because
The,
in the exam, suppose in the qualifiers, such type of question comes about onto.
okay. So see, onto if
Because I am not
if we
familiar
talk
that
about
much with graphs.
so suppose if we talk about our courses, so in our courses till week 4 we have very limited kind of functions. So we have linear functions, right? We have what you can say, rationals,
Exponential.
and polynomials, right? So linear functions were
Polynomial.
always 1 1 and onto y is equals to mx plus c, right? Those are always 1 1 and onto. Okay, rationals we don't know. Here we have to check something. But in general, rational functions, it's very difficult to judge if they are onto or not. But if you have a simpler form of rational, that means y is equals to some mx plus d upon nx plus c type of thing, then yes, it will be onto. Or else, let's skip this case. Because for rational it's kind of tough to compute. But now let's come to polynomials. So we can observe polynomials. So in polynomials we can distribute it over two cases. So we forget about linear function. Linear functions are very easy. They will always 1 1, always onto, because this is equation of line only. Rationals, it's a little hard to compute, but let's go to polynomials. So over polynomials you can have a even degree polynomial and you have odd degree polynomial.
By end behavior, we can interpret.
Correct. So even degree polynomial will never be onto. Why is this so? Because if you find out the end behavior of even degree polynomial, either they entirely go to minus infinity, or they entirely go to plus infinity and plus infinity. Okay, but in both cases, there will be some y values which we cannot say that those y values are taken. Okay, so that's why even degree polynomials can never be an onto function. Okay, so never onto. Now, what about odd degree polynomials? So they are always onto. Because by the end behavior, odd degree polynomial will either go toward infinity and minus infinity. Either this can happen or this can happen. Infinity and minus infinity.
Ma'am,
Okay,
if
but in
it will
both
not go
cases,
infinity, ma'am, it is going infinity because for domain we are taking R. Suppose if I take for SQ function, the domain is 0 to 3, then it will be onto or not.
no, then it won't be onto. Because obviously, if you restrict domain, then it won't be onto. If you restrict domain, the codomain will also get restricted. Or if you are assuming codomain as a real number, then obviously it won't be onto. Okay, so if you restrict domain, they won't be onto. Here I'm talking that if they are on real numbers, the whole set of real numbers.
Madam, when you restrict domain means again the range should be within the domain only, no? It will be onto only, no, madam?
But codomain depends, na. Codomain they can take as a whole real number. Codomain does
Actually,
not
the
yeah,
onto function means that range will be equal to
equal to
codomain, if I am
codomain.
not wrong.
So if they are restricting domain, they are not changing anything in codomain, then range can't be equal to codomain. Right? For example, if you are saying about x cube graph, so suppose this is x cube graph. If you restrict from 1 to 3, and if you say f is a function from 1 to 3 to the whole real number now. Now this will become codomain. But the range will be 1 cube will be 1, 3 cube will be 9. 3 comma 9, 1 comma 1. Now this will be our range. That is range of f will be 1 cube to 3 cube.
So that is the
Which
subset
is
of
1
real
to 9.
number.
Which is a
Right.
subset of real number. So now in this case, it won't be onto. If you restrict the domain, obviously the properties will change. Okay, but in general, if you have any polynomial, so every even degree polynomial can never be an onto function. Every odd degree polynomial will always be an onto function. Okay.
Can even degree polynomial be onto function?
No, it can't be an onto function na, because of the end behavior. You know the end behavior of polynomial.
In
Either
exceptional cases, I am saying.
there is no exception because for every even degree polynomial, the end behavior will be same. It won't change. Either it will go entirely plus infinity or minus infinity or same thing, right? So that's why.
Even degree, by even degree, you mean highest degree, right? Highest even degree.
Degree means highest power of that polynomial. Highest power of x. Okay. So the easiest way for judging onto is graph. If you are not able to getting by the graph, you can use this fact that every linear function is onto. In polynomial, even degree polynomial never onto, odd degree polynomial always onto. Or if you get a combination of some other function like a rational function, there you have to check. Okay. So it depends on rational functions. I cannot say anything about rational function. Those are onto or not. Okay. So that's all. But mostly the graph will work, or mostly they won't ask you the ontoness. Okay, because onto function are little bit on for judging ontoness is a little bit tough. Okay, but if you know the function very well, it's not that tough if you know the graph and
Yes.
all.
Can you convert graph to onto function or give example? How can we interpret from graph? It is
So
onto
I
or
I
onto.
see graph means what you have to do. You have to draw several horizontal lines, and every horizontal line should intersect the graph at least once. If this is happening, then that function is onto. Okay, so I'll write it down. So for onto, draw several horizontal line, and every line, and if every line is intersecting the graph, then it is an onto function.
At most,
If it's the graph in only one point or more than one point is also okay.
Yeah,
no,
if it
ma'am,
is intersecting more than 1 points, that is also okay.
and at most 1 point, then
Yeah.
1 to 1,
So,
right?
at most ones means 1 1.
Okay.
If at least one means onto.
Okay, ma'am. Okay, got
So
it.
1 1 means Again, for 1, 1 also we use horizontal test, but there we want at most once. And in on 2, we need at least once.
We have to intersect the line if 2 points are getting, then it is
If 2
on.
points are getting, then it's obviously not 1, 1.
Not one.
Okay.
And if for on to,
For on 2, if no point is intersecting. Okay. So
okay,
this is yes. And for saying no points, and here more than 1 points. Sorry, I have written in wrong column. For on 2, if there is no point, no point, and here more than 1 point. So that means if you are checking for 1, 1, and if you get any horizontal line which is intersecting the graph more than once, then that case you will say that this graph is not 1, 1. Okay, so I'll draw it here case by case. So suppose I have a graph and every horizontal line is intersecting here at what I have written at most once, right? At most once. So then you can say yes, it is 1, 1. And if there is a horizontal line which are intersecting more than once, so you'll say no to 1, 1 function. Okay. And if every horizontal line intersecting the graph, this is the graph F. Okay. So if every horizontal line intersecting the graph
At least once.
at least once, thank you, at least once, then you will say yes to on to. And if it is intersecting the graph at no points, then I'll say no to on. Okay, so you can see these cases. And the reason is very simple. If a line intersect the graph, you will get a point with coordinate a comma f of a. So you have to interpret now. If you will get two same points, then what are the
just
coordinates?
one second, I'll write this.
Yeah, you can write. And I'll also share the PDF too. Yes, so this is the one thing. Now we just left with the equation of line and
Excuse me.
SSE.
Without two graphs?
Without graph for 1, 1s, we have two statements, those x1 not equals to x2, or else you can find a counter points. So that means if you are able to find two distinct inputs for which you are getting same output. This can use for 1, 1. For undo also, you just have to rely on the definition. That means for every b, you have to find an a on which if you apply the function, you will get b back. Okay, so that's why for onto it's
Below two
difficult to
graphs?
follow the definition.
Show me the below two graphs.
Okay.
Okay, thanks.
Ma'am,
Okay.
excuse me.
Yes.
Ma'am, can you please give an example of a graph which is actually not a function?
Ma'am, just 1 second, can you
The
down?
circle. The graph of a
Just
circle is
one
not a function.
more down.
Except circle, any other graph
Except
is there?
circle,
Ma'am, out
yes,
front chill.
Ellipse, we can say. Ellipse is also not a
ellipse
function.
is also not a function. Ellipse is also not a function. Or you'll draw something like this type of function. This is also not a function. Because here one
2 points.
vertical line intersecting, right? Here also one vertical line
2
intersecting.
points.
Right.
So few,
Yes.
Can
ma'am,
you
is parabola a function? Means few parabolas
Parabola is
cannot be a
function, but this type of parabola is not a function. This is different kind of parabola where the y is in squares. So this parabola will have x is equals to 4ay square type of form. So it's not a parabola. We won't treat it as a parabola. So we'll treat parabola only for us, parabola is just upward parabola or downward parabola. Okay.
Okay.
So we won't treat those type of parabola here.
just can you down the slide just once? More down. More. Okay.
Ma'am,
Last
what
one.
will a graph of bijective function look like?
So bijective function graph will satisfy these two conditions, that at least once also and at most once. So in bijective functions graph, every horizontal line will intersect the graph exactly at one point. Exactly at one. For example,
It
the
would be
graph of
both
a straight
onto and
line.
into, like x square. Sorry, not x square, x cube. The graph
So
of
you
x
can say
cube
as
is
x
a
cube. X cube is a bijective function. Okay.
any odd to the power function, they are onto function, we can say.
Onto, but they need not to be 1 because of the same thing, right? For example, I'll draw a polynomial of odd degree, so you can easily think
X
that,
cube minus x, then you can take x cube minus x.
right? That is also work, right? Any random polynomial of odd degree. So odd degree polynomial will always onto, but need not to be 1. Okay.
X to the power 5 once, please show the graph. X to the power
X
5.
to the power 5's graph is also same as x cube, but it will get little bit flatter over the 0 point, and it will get a little bit straight over here. So something like this. Okay, something like this will be the graph. It's
So
similar to x cube.
x to the power 5, x to the power 7, x to the power 9,
7,
all will
right?
be bijective
Bijective
functions.
functions.
More
Right.
steeper on the x-axis and y whole axis. X-axis is more steeper.
Right. Okay, so let's go to equation of line. So I think in lines you guys can remember all the formulas, right? So the basic formula is y is equals to mx plus c. M is the slope. So if you have 2 points, you can find the value of m to be y2 minus y1 upon x2 minus x1. And we know that there are two types of line, horizontal lines and vertical lines. So for horizontal lines, the slope is 0. And for vertical lines, the slope is undefined. Then you can find out the reasons why these things are happening. Okay. Now the another thing is the slope is also defined as tan theta, where theta is the angle between line and x-axis. For example, if this is our line, this is our line L, and this is the angle theta. So if you compute the tan of theta, you'll get a slope. And why is this so? That's also proof is in the lecture. So if you'll get time, just go and watch that proof. Okay. After this, we have several formulas: area of triangle, the section formulas. Those are just formulas. You just have to remember the formulas and apply to the question. You'll get your answer. Okay. There is not much concept related. So can I jump to SSC direct now? If you guys are okay.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yeah.
Yes,
Okay.
ma'am.
Because here just formulas are there. So you just go list out a formula and remember them.
Ma'am, I have a little dot in.
Hmm.
1 second, ma'am. Ma'am, when we try to find angle between two lines, okay,
Mm-hmm.
then I think there's a two concept of theta and phi. So please elaborate these two things.
Theta and phi.
Yeah.
So the formula is that tan theta, if theta is an angle between L1 and L2, is some modulus of m1 minus m2 upon
Yeah.
m1
Yes,
plus
ma'am.
m2 upon 1 minus m1 m2. I think this is the formula, or minus plus. You can check.
No, I think you have
No, ma'am.
given, maybe you have given opposite.
Numerator.
M1 minus M2, and
Yeah.
downside it will be 1 plus M1 M2.
1 plus m1 m2. So
I'm
this is
sure
the
about that.
formula. So what is your doubt here? Theta,
Now,
phi.
draw two line and then.
Okay. So suppose these are two lines, L1, L2.
Okay. Okay.
So
No,
this will
ma'am.
be your angle theta.
Yeah. And external angle is.
So see, this L2 line will form some angle with x-axis. So let's name it to be phi 1. And this L2 line, L1 line will also form some angle with x-axis. Let's name it to be phi 2. So that's how we gain this formula, tan theta. So what is happening, if you see the figure, this theta is nothing but this whole angle phi 2 minus with the angle phi 1. Correct? If you subtract the phi 1 angle from phi 2, you will get the theta angle. So now we want to interpret what is theta. So we know that if we have the angles here, we know that the slope m1 will be nothing but tan of phi 2. Sorry, m2. What I am writing here, 1 to replace that. So the angle of line L1 is phi 1, angle of line L2 with x-axis is phi 2. Then clearly theta is nothing but we are subtracting phi 2 from phi 1. Phi 1 minus phi 2. Okay. So now we know that the slope of a line L1, which I can write as m1, is nothing but tan of phi 1. And the slope of a line m2 is nothing but tan of phi 2. So now what we will do, we want to find out tan theta. So tan theta will be tan of phi 1 minus phi 2. So here we know the formula that this is same as tan of phi 1 minus tan of phi 2 upon 1 plus tan of phi 1 into phi 2, which is same as m1 minus m2 upon 1 plus m1 m2. Right? This is the value of m1, this is the value of m2. That's how. Is that the concept or anything else?
Posted, ma'am, in the chat box. The
Sorry, what?
figure I posted. I posted
Oh,
the
you
figure in chat.
figure. Okay, so here what's your doubt? You want to find the angle phi, right?
No, ma'am. What? Please elaborate what is phi and what is theta.
Okay. So see, such type of lines are there. This is the angle alpha 1. This is the angle alpha 2. And here is the angle theta. And here is the angle phi. Okay. So what you can do, you can interpret these angle in terms of alpha 1 and alpha 2. Because alpha 1 and alpha 2 are the angle of the lines L1 and L2 with x-axis. Okay. So here theta is the angle between the line L1 and L2. Because this is your alpha 2. So if you enlarge the scale here, you can say that, okay, this is our alpha. This angle is our alpha. So here theta is the angle between two lines. Between line L1 and L2. But what is phi? So phi is actually 180 degree minus of theta angle. Because this is the straight line. This is the straight line. And here we have some angle theta. So we know that the total angle is 180 degree. The remaining angle is phi. That means here phi is the angle between two lines. And theta is the angle between two lines. And phi is 180 degree minus of that theta. Okay. So this is your phi. Is that clear now?
We say phi. Can we say phi is also angle between both lines L1 and L2?
You can say although, but it's not the exact angle what we found between two lines. So
I'm able to solve all questions, but I have I'm confused. Just confused.
So suppose I just have phi angle here. So this is the angle phi, right? So this is the angle alpha 1. And here is the angle alpha 2. So here you can say that phi is nothing but also. So let's see. So we got this relation. Phi is 180 degree minus of theta, right? Which is nothing but pi minus theta. So if you compute 10 of phi, you will get 10 of pi minus theta. So no, they will give you, I mean, different values will come. So no, this one. So here phi is actually we can say alpha. What is? Oh, sorry. Phi is this
Then
angle means phi is
negative
the
will come.
whole angle. Negative values we have to take, right? So that means we have to go below the x-axis here. So if this line L1 is intersecting angle alpha 2, this angle will be 180 degree minus alpha 2. So it means phi is in negative side. So let me clear all things.
Ma'am, please could you repeat
Yeah.
why phi is negative?
So see, this is phi. So ultimately, this angle is alpha 1. Right? And what is alpha 2 angle? Alpha 2 angle is this angle. So if you want to find the angle phi, what we will do, we have to take the negative of alpha 2 angle. That means this pi minus alpha 2 angle, and then add it with alpha 1. So if you want to consider phi in terms of alpha and alpha 2, so phi is nothing but pi minus of alpha 2 plus alpha 1. So that's why phi is not an angle between angle of lines. So we usually consider the angle to be this angle. This is the angle between two lines. But phi is something else. And what is that angle? So if you take, we know that this is the 180 degree. So if there is some angle, this will be 180 degree minus alpha 2. So this angle is alpha 2. This angle will be pi minus alpha 2, 180 degree minus alpha 2. And if you combine the whole angle, you will get the angle phi. That's why alpha 1 plus pi minus alpha 2. That will be your angle phi. That's why it's not same as the angle of line.
Okay, ma'am. Got it. Thank you
Okay.
so much, ma'am.
Yeah.
Ma'am, suppose two lines are there which have negative
Why is
values.
it negative?
Suppose M1 is minus 2 and M2 is minus 3. Which one has greater slope? So what would you say?
M1 is?
Minus 2 and M2 is minus 3. Which one
These slopes cannot happen because
minus 3, suppose.
minus 3.
Yes.
Yeah, these slopes
Suppose
cannot happen. No, sorry, they can happen. Sorry. We are talking about tan theta.
Which one has greater slope? So how will you judge?
M1 is minus 1, M2 is minus 3.
So how?
Right. So M1 will have greater slope because if you know about tan theta function, so tan theta's graph, I just want to tell you by graph because it's easy to see that the tan theta's graph will behave something like this between minus pi by 2 and pi by 2. It's minus pi by 2 and pi by 2. Okay, so if you have negative values, then I mean this value is minus 1, then this value is minus 3. So this will have a greater slope. And minus 3 will have a lesser slope.
For M2, you will get alpha 2 greater than alpha 1. Alpha 2 that would be greater than alpha 1. That's
Yeah,
why we
correct.
are
Alpha 2
getting.
will be greater than alpha 1.
So we take the alpha from positive axis, no? So
Right.
So it should be the M2 should be greater than M1 if alpha 2 is greater than alpha 1.
Yes, you can say because 10 is an increasing function.
10 is
So
increasing function from minus pi by 2 to plus pi by 2.
Minus pi by 2 to plus pi by 2.
That is increasing. So that's why we can't say if alpha 2 is greater than alpha 1, then we can say tan alpha 2 that should be
greater than
tan alpha 1
alpha 1
because that is increasing function. So why I'm not saying here M1 is equal to minus 1, M2 is minus 2. So alpha 2 is greater than 2. Why I'm not saying
I'm not able to understand your question. Can you repeat once?
मैं कह रहा हूँ कि tan theta function increasing function है from minus pi by 2 to plus pi by 2. Alpha 2 का value alpha 1 से ज्यादा है. So that means tan alpha 2 that would be greater than tan alpha 1. So we are getting negative values. Tan alpha 2 here we are getting minus 3 or tan alpha 1 we are getting minus 1.
Minus 1.
But it is not satisfying here.
So here, what is happening, since we are not considering minus pi by 2 to pi by 2, we are considering 0 to pi. Okay, so 0 to pi, the graph of 10 looked like this. If you know, something like this. This is the graph of 10. So what happened, if we are at 0 to pi by 2, So in this case, the graph is increasing. But if we take pi by 2 to pi, in this case, the graph is decreasing. So here it can happen that alpha 2 has value, I mean, the angle is greater than pi by 2 and alpha 1 is less than pi by 2.
Madam, both are increasing only, no, madam?
Yes, ma'am. Pi by 2 to pi also increasing.
Increasing, both are increasing, no, actually?
Both are increasing?
Yeah, from
I mean, the graph of 10 look like something this type of. So if you are treating from 0 to pi by 2 and then pi by 2 to pi, 10 pi is minus 1, 10 pi is 0, sorry.
all these graphs are increasing only, no, madam. It is not decreasing.
Yeah, it
It's
is
all
increasing.
increasing.
It is increasing, correct.
Yeah.
But since we have that minus 3 and minus 1, right? So this is minus 1, minus 3, suppose this is minus 1. So correct, yeah, this should not happen. ये नहीं होना चाहिए था यहाँ. This should be minus 1, this should be minus 3. Something is wrong here. If you give me the exact question, then I think I'm able to solve. Okay, so let's go to SSC. So what is SSC? Again, see, SSC is nothing but a way to calculate and one type of error. So what we want, we have some data set and we have some expression which justify our data set. We want to know that up to which capacity that expression is valid to our data set. That means we want to find an error between the expression and the data set. Okay, so this error can be calculated by SSC. So SSC says we have a particular formula which says that that the SSE is actually equal to summation i's ranging from 1 to n. If you have n data sets, so if you have n points here, x1, x2 up to xn, and relatively y1, y2 up to yn, then the formula says summation i's ranging from 1 to n, yi minus m of xi minus of c the whole square. So instead of this equation of line, you can take any f of xi. Okay, any function you can take, you will find out the values and square it. So this is the formula for SSC. You can find out the formula. Now there will be two types of question. So one is simply calculate the SSC. And the second one is find the best fit. So best fit means you have to find that expression or that function which give us minimum SSC. Okay, so for this problem, what you can do, you can find the value of SSC for each and every given expression and then choose the minimum one. Or once you or you can just apply the formula of SSC, and after applying, there will be some constant in that function. Just find the
This
minimum
formula
value.
is little bit complicated. Can you use it other one?
This formula is saying just find the error and square it. So that means y1 minus m of x1 minus c the whole square, then plus y2 minus m of x2 minus c the whole square, then plus, and so on. This is
Yes,
the
ma'am. There
formula.
is that one y1 minus y mean the whole square.
Correct. Or else here we are taking equation of line y is equals to mx plus c. But instead of this, you can take any function. So suppose f of x is function given to you. So you can replace this as y1 minus f of x1 the whole square, then plus y2 minus f of x2 the whole square, then plus, and so on. That means it need not always be a line. So if you take minus sign here common, you will get x1 plus c. Right? So that's why I have written f of x. So both formulas you can use. So I'm just saying that if you don't find m and c, if some other function is given, so suppose x square is given to you, or x square plus c is given to you, or x square plus 2 is given to you. And if they ask find the SSC, then you have to apply the second formula. And if the simple line of equation is given, then you have to apply the first. Okay, is that okay? Clear?
So, madam, if first step is given, it's already linear function means, then that will be the best fit, no, actually?
No, it's not always the best fit. It depends on the given question. Sometimes quadratic function will always be the could be the best fit.
Ma'am, please elaborate the quadratic function.
Quadratic function means what?
No, मैम मतलब मेरा मतलब है क्वाड्रेटिक फंक्शन वाले केस में कैसे अप्लाई करेंगे वो थोड़ा सा elaborate.
हाँ, so quadratic function वाले केस में you just have to substitute here the quadratic expression in place of x. So suppose
And
ax square
take one
plus
example.
bx. I actually don't have an example over SSC. If you guys have, you can just paste in the chat.
You can
There
do
is
some
an
graded
option in mock
assignment
test. Can you solve
or
for
activity.
it is based on SSC in mock test?
Which question?
The last question, question number 12.
Okay, let's see how the mock. Can you take a screenshot and put it in the chat?
This is big. I'm trying.
Yeah. Question number what? This one, a well-educated carpenter is
Question number
asked to
10
cut.
to 12.
Okay,
10 to
so
12.
this one, no? That a well-educated carpenter. Is this the question? Well-educated carpenter starting with?
Length of bones. It about length of bones.
No. So I think in my mock they haven't put this question. No, I don't have this question in my mock. Can you send the screenshot?
Yeah, I'm sending.
Someone send it.
Then I have shared in the chat box.
Okay. So a function f of x, which is the best fit for the data given in table 1, recorded by a student is this one. Now see, here the function is given to you. So that means for calculating SSC, you have to use this formula. Okay. So now plus c is there. So what will be the value of c so that SSC, sum square root, will be minimum? Okay. So this is the NAT question. So the question is f of x as some minus of x minus 1 the whole square into x minus 3, x minus 5, x minus 7 plus c is the best fit. Now we have to find the value of c, and the data table is given to us as 1, 2, 3, 4, and 5. We have values as 4, 18, 4 minus 24, and 3. Okay, so in this case, what you have to do, it's already given that this function is a best fit. So first what we'll do, we'll calculate SSC. So here we have 5 points. We'll apply the formula that y1 minus f of
First,
x1 the whole square plus, yes.
I can explain. For every value of x, we put an equation, right? Like x is 1, then we put 1 and whole the equation.
Correct,
and
correct.
get the value. Then we minus that value with 4, that y
Correct.
value. Then
Right.
square and all
And
this same with all and
same
add.
with all
And we
5
got
points.
yes.
Whole square.
Then
So if
add
you do
the
with
whole.
first point, so we have y1 to be equal to 4. This is your y1, right? So that means 4 minus f of 1. So if you substitute 1 here, so you can observe that this bracket will become 0. That means this whole quantity will become 0. We're just left with
0.
c.
4
So
minus
that
0
means
is
c is there,
0.
okay? So don't forget c. So c will create a problem here. Not create a problem, it will
We
give us
get
a
a
quadratic.
value of c after. We get a quadratic equation adding the whole.
Correct.
So please
Correct.
let
Then
us
we
speak.
put that quadratic equation in minus b by 2a. Then we
Sir,
put
Right.
I
value
am
c.
not able to understand that. Please let her speak.
Yeah, just wait. So I'll
Okay,
explain.
ma'am.
So see, what is happening here? F of x is already given. It is already given that this is a best fit, and some data is given to us. Now, since f of x is given to us, we'll apply the formula of SSC. So as you apply here, we need to substitute the values of f1 and x1. So the values of xi's are 1, 2, 3, 4, 5. So we'll one by one substitute these values in f of x and get the value of f of xi and substitute that value in our formula. So for example, here first value is y1 value is 4, so we'll take 4, and then minus of f of x1. F of x1 means x is equals to 1. But if we substitute x is equals to 1, this whole term will become 0. We'll just left with c. Now plus the second value, which is 18 minus of, if you substitute 2 here, we won't get only c, we'll get some value. So suppose what will be that value? So what is f of 2? So f of 2 will be minus of 2 minus 1 the whole square, that means 1 only, into 2 minus minus 3 will become minus 1, 2 minus minus 5 will become minus 3, 2 minus minus 7 will become minus 5. Now there are 1, 2, 3, 4, 4 minus and 5 3s are 15. So that means 18 minus 15 minus c, the whole square, and plus c is there, right? Okay. So that's how we compute the expression for each and every bracket. So for example, the next I can compute.
Ma'am, note minus.
Dot minus.
When,
So 2 minus 1.
2 in.
So when you put 2, 2 minus 1 will be 1. And this minus is there already. Na?
Oh, sorry.
Yeah. Okay. So that's the 18 minus 15. So if you substitute now x is equals to 3, because of this bracket, the whole thing will become 0. We're left with c only. So that means with 3, the value of y is 4. So 4 minus c, the whole square again. And now plus with, if you substitute 4, then we have to find the value of f of 4. So what is f of 4 now? So f of 4. So this is minus of 4 minus 1 will become 3. 3 whole square will become 9. Into 4 minus 3 will become 1. 4 minus 5 will become minus 1. 4 minus 7 will become minus 3. So again 3 minuses are there, minus 27. So that means plus of minus 24, minus minus plus 27, and minus of c the whole square. And then at the end, if you put 5, you will get 0 again. It is 3 minus of c, the whole square. Okay. Now that means we have 2 of 4 minus c the whole square. And here plus 18 minus 15 will be minus, 3 minus c the whole square. Plus 27 minus 24 is again 3 minus c the whole square. And again plus 3 minus c the whole square. So ultimately what we have twice of 4 minus c the whole square plus thrice of 3 minus c the whole square. Now this is just a quadratic expression, we can solve it. After solving, you will get some quadratic expression. So let's see what is that. So it's twice of 16 plus c square minus 8c plus thrice of 9 plus c square minus 6. So this is 32 plus 2c square minus 16c plus 27 plus 3c square and minus 18. So ultimately 2c square, 3c square, 5c square minus 18c minus 16c will become minus 34c, I guess. And 27, 32. So this will become 5 and 9 and 5, 15. So now here you will get a quadratic expression. So what you have to find out, if this is your best fit, so the claim is if this f of x is your best fit, it is only best fit if this quadratic expression gets its minimum value. Okay, and we know that it's an upward parabola because of plus 5 sign. It's an upward parabola, so it will have some minimum value at its vertex. So what you have to do, here you have to find the x coordinate of vertex. That will be your answer. Okay. So ultimately, being best fit means the value of SSC is minimum. That's what we have to compute. Is that okay?
Yes, ma'am.
Okay.
Coordinate
Minus b by 2, I just have to compute.
minus b by 2.
So something 17 by 5 will be the answer, right? 17 by 5.
Okay.
3 point.
Okay.
Okay, so there are 2 more questions. So
Yeah,
here
can
also,
you can discuss tomorrow, ma'am, because time is up more
yeah,
than
time
20.
is up. Okay, so yes, you can discuss these questions tomorrow also. There is another revision session, so you can discuss that. Again, I'll upload this PDF over the calendar. So in calendar, you will find a link. From that link, you can download this PDF, the notes.
Another
the
session
session
is
notes.
day after tomorrow, right?
Day after tomorrow, yeah.
Sir, one suggestion,
Yes,
sir.
ma'am.
Generally, when madam and the other students are available, no, we have to keep continuing. Once you lose that, then you will not have time because one more session will be there for week 3 and week 4, which will be more tougher than these 2 weeks. So for that, it will go up
Yeah,
to 11 o'clock also.
yeah,
And
that's
since
correct.
war is not available, no, it will be available in the YouTube. It will be uploaded. So if we want to leave, we can leave and we can watch the recording.
Yeah, but
Okay.
those SSC questions are only there. So
No, no,
I'll
I'm just
explain.
telling for future, when
Mm-hmm.
instructor is ready to take the class as a student, whoever is available, we can be here. Whoever is not available, then they can leave.
Correct,
But once
because
you
actually
lose,
there will be time when we have to I mean not me. There is one sir. He took the session up to 12 or 1 p.m.
yeah.
in the morning.
So
So
I am not there, you are
happens.
not there, don't worry. Even one student is there with him, we will take. But
Mhm.
advantage is for all of the
You can
students who
watch
are
YouTube.
not able to,
Okay,
yeah, you
okay,
can
okay.
see
If
the
Yeah,
you want to
YouTube.
explain right now, yeah, you can. We are
correct.
ready.
Ma'am,
But yes.
Let's
I
back to work.
No,
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 actually
sorry,
I
I
have
I'll
just
be,
one.
told this.
ma'am, it's okay, it's okay.
Yeah, I think whoever has
Ma'am,
told, they understood my point.
Yeah,
Uh,
we
yes,
understood.
Madam,
Thank you, Naresh.
if you are comfortable to continue, you can please continue,
yeah,
madam.
so sure, ma'am, sure. If you are comfortable, then continue the session.
no, actually
I'll
I'm
discuss
It's
little
the
right.
exhausted.
discuss.
You
I'll
are
discuss the both session, discuss the both condition of SSC at least, please.
Those conditions we
Both condition which you written, which you have written. Just
so
like
one condition is this best fit. So calculate SSC is very easy. Just apply the formula, calculate SSC.
yeah, yeah,
Right. For best
yes.
fit, one type of question is this question, which we just solved. That you there will be one constant in our function, and that constant value you can find by just watching the SSC's expression. So here, as we computed SSC, at the end we got some quadratic expression, and we know that the minimum value of quadratic expression will be at its vertex. Okay. So this is a one type of question. So another question will be the reverse of this. Matlab, in that you will have some data set, and then they will ask you what will be the best fit among the given options. So for example, there is one question pasted in the chat. So here the question is a question A, student calculate the living uh, height of a person using the given formula. The formula is given in some ways. Height are calculated by respectively. Choose the correct set of options. So this is something else. Is this the whole question? Okay, the above one is the whole question. Okay.
Yes,
Uh, so what is this? The length of a bird's bone to estimate the living height. So the height of the subject. Calculate the height based on the length in the bones. Okay, so if you have FHRT, and these are the formulas to find out the bones. So what is the question here now? So question A, student calculate the living height of the bone using the formula. Okay, so you just have to create a function h just by substituting the HF, HS, HR and HT, whatever given in the above options, above table. Okay, so you'll get your formula. Right. So who posted this question? Manu, right? So what you have to do, just take that the expression for HF, HH, what R, HS, what is this? Take these expression and substitute into H is equals to the given condition and calculate it. You will get your answer. This is not related to SST. It's just a general question. Okay. Uh, yes, I guess that's it. So the next type of question could be like this. So suppose question is there. Some information will given to you, some verbal information. Here you will have some data set. X, Y, some data sets will be there. And here some options will be there. And the question will be which of the following can be a best fit. Okay, so what you have to do, you have to calculate the SSC for each option. And whichever gives you the minimum SSC, that will be your answer. And so this is the pathway to tackle this kind of. These will be easy. The first one will be easy. This will be easy. The only a little bit tougher, you can say, like this type of question.
Ma'am, excuse
At
me.
the end, yeah.
The SSC, it will be of how much weightage?
There will be at least one question. So 1 or 2 question, you can say.
Okay, ma'am. So
That's
suppose.
the pattern so far.
How
Okay.
many questions in total will be there?
How many?
Questions in total for the exam?
Questions vary from 12 to 15. It depends on who sets the paper. So there will be some questions of 2-3 marks, or there will be some questions of 4 to 5. So 12 to 15 you can assume.
So maximum weightage out of which parts?
Maximum weightage, actually there are only 4 weeks. So each week has one favorite topic, right? So for example, in week 1 relation functions are there.
No,
In week
actually I didn't want to ask that way. Means actually in week 2, suppose the
Week 3 and week
straight
4
lines, that
has
chapter,
more weightage.
coordinate geometry is there. So
Yeah,
in
yeah.
coordinate geometry, which part will be of maximum suppose weightage?
this actually I don't exactly know this time.
Okay.
But you can say if coordinate geometry is there in week 2, parabolas are there, so there will be obviously a question from minimum maximum value of parabola, something like that, maybe.
Okay.
So exact weightage I actually don't know.
So actually I was asking this because I had not read SSC. I had actually left and I had omitted and then jumped to week 3 and week 4. That's why I was asking.
Okay. Yeah, so from week 1 I can say the question will be on from relations and functions, and Venn diagram. So these 3 will be, you can say, important topics, but it is possible to get questions from other topics too. So if you get some other question, you are able to at least solve them.
Okay. So I was just one doubt that SSC will be just one or two question.
1 or 2 questions.
Okay. So suppose if I omit, so it would that much marks would not be lost actually.
So one question will be of 4 marks. So 4 or 6 marks you will lose.
SSC is very important actually. It's a mandatory question for any
Mandatory question. That's why I can say there will be at one question there will, and SSC is
What
not
about the
Okay.
sorry? What is the importance of PYQs? Will we get the similar questions or how, madam?
Similar questions means MCQs, NATs, those type of questions only. Yeah, PYQs, weightage of PYQs. Yes, you can find some similar type of questions from PYQs also.
No. What I'm asking is for the qualifier, will there be any similarity of questions like the previous year question papers, or it will be totally...
Right. There will be a little bit similarity of previous year question papers. That means pattern, you can say. Pattern means number of questions, the concepts, you can say.
And where can we find PYQs?
Supplementary content, I think they have uploaded some PYQs.
I'm sorry to interrupt, but
Another place you can find PYQ is I think unknown IITians, that website also you can go.
No. If ma'am permit, then ma'am, may you permit, then I can share the external website.
Yeah, you can share the sheet.
Yeah, I share.
One second, ma'am.
Someone shared it.
What is your search your in browser? Practice space dot something. Choose practice dot space and you get.
Okay. So yeah, that's all for today. Whatever we left, we'll discuss in the next session. Okay. So thank you guys for joining. I'll upload the PDF over the calendar.
Thank you so much, ma'am.
Thank you, ma'am.
Ma'am,
Thank you, ma'am.
Thank you, ma'am.
And a good night.
Yes.
You're troubled.
Yeah, someone say something.
Ma'am, can you please just once...
Now you are audible.
Once say the formula of SSE.
Sorry, what?
The formula of SSE.
So formula of SSC is that yi minus f of xi the whole square summation.
Okay.
For any function, you can say.
Yi minus xi whole square. Okay.
Minus f of xi the whole square.
F of xi.
Hello.
Yes, Shweta. Yes. Hello. Your voice is not clear.
Hello, madam.
Yes.
Yeah. What is the importance of the mock? Will we get similar questions like mock or how, madam? Mock session.
Yes, you can get similar type of questions from the mock too. So it's better if you solve. I mean, it's not compulsory to solve, but it will be a good practice if you are done with all practice, all graded PYQs.
That is done, madam. The graded actually is done, and PYQ I have started working on, but this mock alone it is little difficult to solve.
So if you have done those many questions, I don't think mock is that. Yeah, so mock contains some of the difficult questions. So that type of question won't be there.
Achha, but somebody is saying that the 50% of the question will come from mock only.
No, that's not the case always.
Achha.
50% is too much, right?
No, I'm just
If
asking.
you're solving PYQ, so it is possible to get similar kind of question from PYQs. Again, not exact, but
No,
similar.
exact will not be there, madam, because it will maybe everyone can reach 100%, right?
Right.
So, anyways, madam, thank you so much for the valuable time.
Yeah, thank you guys for joining.
Ma'am, excuse me. The activity questions are important that much. If suppose I have not solved or skipped activity questions, but I'm solving PIQs, so would I be able to qualify the qualified exam?
Yeah. PYQs are much important than activity.
Okay.
Okay.
Suppose if I have not watched any session, means suppose I have missed few of the means suppose I have missed week 4, but I am attending the revision session and I did the PYQs. So would it be sufficient for qualifier?
Yeah, I think for qualifying it's sufficient.
Okay.
How well this concept are used, or is helpful for the upcoming week 5 to week 10 and the end exam? Madam?
Yeah, so actually when we define limit continuity and other functions, exponential logarithmic functions, so this basic knowledge is actually required. So for example, so far we are just discussing about some functions, linear, quadratic, polynomials, now exponential, then logarithmic. So there we use the function. Obviously, since we are talking about function, you should know what is a function. Also, one onto functions.
Okay, and what about the final usage of these concept in ML?
In ML, so in ML, actually, I haven't seen the courses.
No, I have gone through the courses from this Udemy or from my friends. They are saying the usage of mathematics or statistics is not that in depth.
That much.
So they are actually this supervised and unsupervised or something like that. They are saying.
Okay, so I actually don't know what is the
So brother, so in ML, which concepts are used more actually? Which subjects concept are used more?
That I don't know. For that only I'm asking actually.
Yeah, actually, I also don't know. I haven't gone through the course ML.
So that's
I
what
also don't know ML.
I know everywhere the people are asking for only the projects, madam. What projects you have done actually? That is the main thing they are asking. Even for a passed out, it is okay. But for people who are working and who have last 10 years working in an organization or somewhere 5 years gap, 6 years gap, they are asking for a real world project actually. They are not taking the candidate as it is.
Oh, so yeah, but it's a qualifier course. So anyway, you have to do. Anyway, maths will be used in
Maths will be used.
indirectly maybe.
Acha.
But although calculus is there, so I don't know how calculus is applicable in CS or the other
The
programming.
linear algebra and calculus is there as per some glimpses from somewhere the other, but we don't know what exactly because I thought that you are into the BS level.
Yeah, so I'm just I know maths and stats. I don't know anything about programming, but yeah, I have seen some of the courses. So I taught graph theory, so I know graph theoretical approach, but calculus I don't know.
Sure.